All right. Here we go. So hopefully this camera doesn't do this hunting bit. While we get this show on the road, we definitely want to save that. Okay. All right. Let's see. Got text messages at the same time? All right. Now, there we go. Get my bodge parts getting attracted to the magnets. Let's say I don't need this keyboard. All right, so everybody obviously knows that this is a 980, presumably. So I'm going to talk a little bit about this beastie, and then you know, when everybody gets here, I'll go into what's going on here with this cable that's going between the radio, because this one seems to be some controversy, which is one of those why is there controversy questions, because it just seems somewhat ridiculous to me. But I'll get into why there's a controversy. Text message. Yeah. So we got some folks starting to show up. You guys, I think. Nobody has said anything yet, and of course this thing is still. I thought I managed to reset it, but apparently not, because it's doing that shut off the heat thing. Buzz buzz. More text message or email stuff. All right. So one thing I've noticed about these 980 SSBs is this side of the radio gets incredibly hot. This you got an audio amp in here, presumably. I think that one on this side is probably the AM regulator, and this other one's probably the it's probably a series you know, regulator, and it gets incredibly hot. So much so that I really question to me that just seems to be, you know, pretty hot. I've obviously been touching it to cool it down, so I wonder how hot this thing is. You know, 36C is, you know, 37, 38C, 40C, you know, see if it's that one. Yeah, it's this guy in the front here, which I have no idea what it is. 45C. That's really warm, but I think that one can probably be sorted. But anyway, so if everybody is here, I'll discuss the 980 and the other interesting things going on with this cable that's going between the radio and this sort of overshadowed thing that's sort of getting blinded here. This display doesn't have anything on it, so don't worry about that. The program running on this microcontroller is it's a very simple program. What in the world? Buzz buzz. So this anyway, this display doesn't have anything on it. I didn't write any code to draw the display. It's getting random nonsense. So it's not, there's nothing, something's not supposed to be here, so don't worry about that. The program running on the microcontroller is a very simple program. It is basically a counter that's hooked up to this encoder. So I turn it one way, counter goes up; turn it the other way, counter goes down. That counter is then converted into a frequency, which is then sent via some math over to this radio. where it programs this phase lock loop. There's been some noise lately about the 980, and I have said this time and again, this radio can be modified. Yes, it can be. It's not practical to modify this radio because you need to design the whole front panel over again. You know, you have to use their LCD and so on and so forth. It's not worth it. It's just not worth it. So, but can we put it in other places? Absolutely, we can. And that's what these 4 wires here are. You know, we've got a clock, a data, a chip select, and a ground wire, and that's it. So, anyway, so the radio. Let the scope out of here. I was actually probing around this VCO because I was somewhat curious about this VCO because it's fairly broad-banded. The lowest that this radio seems to want to go is around 26 megahertz. That seems to be its bottom. Its top seems to be, see that thing sort of flickery as I jiggle that, but anyway, the top seems to be around somewhere up in 28 megahertz. Now what I was trying to figure out is if that is a there's Mike. Is that a result of hitting unity in the VCO? I also want to point out that the VCO design in this radio is very simple. This VCO is basically a couple of transistors and some passive components. That's it. Nothing else. You know, and if you look down in there, you can see the varactor diodes. You can see the loop filter is right next to it, and you can see the other actives and passives. There's an inductor and some other bits down in there. That's the VCO. I don't think this VCO requires any modification to really do anything. It seems to work fine the way it is. So, for example, when this radio has an out-of-lock condition, like it does right now, this RX TX will sit here and blink because it has an out-of-lock condition. It's just not locked. The reason that this radio isn't locked, and it doesn't matter where I turn the channel. This isn't doing anything. So the reason it has an out-of-lock condition is because it's sending it something that it cannot. It's said basically it can't go there. So, you know, if I turn this, you could see that now it's locked. So I can bring it back out of lock, you know, and I can turn this and bring it back into lock again. You know, this whole thing up here, the counter, this is all a dummy. You know, this is just hard-coded in the radio. So when the radio is on channel 28, 27 to 85, if you notice, I mean, dead giveaways, like you turn the clarifier and it doesn't change, and you know, and all that stuff. It's because it's a dummy. It's just there for you to look at and say, oh, I have a frequency counter. No, you don't. You have a frequency display that doesn't do anything for you. It's basically useless. You know, and that's just, I'm sorry, but that's the reality of this radio. It's useless. It doesn't do anything. So, you know, where's the radio now? It is on 26115. Let me take this camera down because people are going to say, no, it's not. I have quite a few haters, and I'll get hated to death. Okay, so there's the counter. Okay, 26114997. Okay, so I turn this knob. We just turn it a little bit, and I don't know. It's probably, you know, 100 channels. Pretty close. 27515. Well, that's curious. So, over here, turn it like 3 more clicks. and 7545. And that's all that is. Okay? Well, there's another little tidbit. On this radio, you can probably see those tracks maybe down there. They're cut. And you see where I've cut them and bodged them and cut them and bodged them and cut them and bodged them because I've been sort of working on... this camera won't focus. Working on, you know, sniffing it. And that was the prior stuff I did in the past, so I can figure out how this works. If I leave this, these tracks that go over to the SPI bus that go over here, they share some common connections with this bus expander and then go up through this ribbon cable, and I inject my own PLL settings at the same time that the micro, this micro is connected to the radio, it will actually shut down and reset because this micro has countermeasures in it. So if it sees anything on the bus that is talking to the phase lock loop, it seems to shut down. And I've tested that by sending just random gibberish down the bus, and it didn't do anything. It is only when I sent specific data that would be the 224-bit packets that is required to set this up. That's when it got a little bit hairy, and it would reset and do a lot of the kind of, you know, just basically blink and just do some weird stuff so that you couldn't transmit and so on and so forth. It went into sort of a haywire mode. So which is why you have to cut and isolate the PLL. Oh, what's up? So you have to cut and isolate this PLL because otherwise this micro will go completely nuts. So yeah, that's basically the deal with the 980 SSB. So questions, comments, flames. See if I can get this camera back up here on this blasted mount. There we go. If it will behave, I think. There we go. It's behaving now. Good. So that's basically it. I want to be very clear. This radio can be modified. It's not practical. Don't waste your time. Just, I had some elaborate thing that I have to find this prototype. That what I did is you got this pin off here. I've got soldered to the board here, and this is the chip select line for the PLL for the VHF receiver. And so what I was doing is using the weather channel to. I was snooping on the weather channel, so when I saw it's programming the PLL, this PLL for say weather channel 1, I used that to select a bank of 40 channels. So I sort of used it as a band function for the PLL, and that thing used to sit in between this micro and this PLL, and it would monitor the bus and say, oh, it's trying to program the weather PLL for say channel 2. Okay, this is the 40 channels that I'm going to send to this PLL depending on what I get here. So when you change the channel, it would fire off the 224-bit packets, one of which is the reference packet, which is well, we can talk about that incidentally. So what it would do basically is send the 24-bit packet, the first 24-bit packet, which is a reference to the PLL. I would ignore that packet, and then it would send the second packet, which is actually to set the divider and the other divider options, and that's the one that I would intercept that packet, process that packet, look at it, and say, okay, this is for this channel. Hit a lookup table, look to see what the corresponding channel would be on that band, and then fire it off to the PLL. Basically, it would intercept the data and change it, and then send it to the PLL. So I essentially had, you know, what was it, 6 or 7 banks of channels, and that was in this radio. I don't know what I did with that little board, but that's basically what it is. And it was just bodge wires somewhere up here, and it went to the board, and then those bodge wires went and attached to this, and so on and so forth. I can't remember what I ever did with that. But that's all it did, was snoop the bus. So as soon as this was selected, that told it where it was, and then this, and then it, you know, it would do some lookup table in the micro, and then send that corresponding channel on another band. I basically tried to conform to like the Galaxy, you know, banded radios frequency charts. So, but that's the most I could do with this. I had a few people who were interested in that, and they would do it. You lose the weather channel functionality, because you're setting the weather channel to the band would becomes your weather channel, and you're setting the wrong weather channel. So yeah, you know, that was sort of the issue with that. There's two of them. I have the datasheet bits here, so let me get the rest of the pages, because like this is the one page. It's not printed both sides, and you can't read that because the light's so bright. Let's see. This is part of it. Let's see, 92. Here we go. I dropped these things on the floor earlier, and I kind of have to put it together really quick. But I do have the whole data sheet here with the layout of the bits and everything like that. So, good question. All right. Oh, I just dropped them all over the floor again. Oh man, it's not my night. Drop a stack of like 30 pieces of paper all over the floor, and they get all mixed up. Anyway, this is the PLL in question. Okay, it is a BU2630F, or you have a BU2630FV. The one in this radio is an F. I'm pretty sure it's not an FV. No, it is an F. So it is a dual PLL. Okay, so there are actually two physical PLLs on this chip, and they can be controlled independently. The radio is only using one of them, so the other one is just sort of sitting there dead stick. There's no connections to it. The same data bus obviously controls one. You just set a few address bits in the packet that tell it which one of them you are controlling. We have, you know, your typical specifications, you know, how much power, basically power supply voltage, you know, 0.3 to plus 7 volts, so on and so forth. The pins and their type of circuit in them, and then you have the type of circuits. So you can see if it's a couple of diodes, couple FETs, 4 diodes, resistor, and a few FETs, so on and so forth, or some inverters and Schmidt triggers and so on and so forth. Rest of the specifications. This is the timings, obviously. And on the back of the next page is the 2 packets. Okay, so this is 2 of the packets for the transmit, because they call them the transmit and the receive PLL. So this is the two packets for the transmit, and this is the 2 packets for the receive. It was a 95, 96, yeah. So, and they give you examples. So the example here is when crystal is 10.24 megahertz and reference frequency is 5 kilohertz. That will give you, with 5 kilohertz, that will give you, I guess will give you, yeah, that will give you 5 kilohertz steps. So the packets are comprised of, for, let's say we want the reference divider value that we have to set. We're going to set, you know, that to be, say, 1024 for a radio like this. I believe it's 1024. I have to look at the code. That's going to be controlled by the from least significant bit to most significant bit. The first basically byte and 6 bits of the next byte. So the first 13 or 14 bits, I'm sorry, of the R register's packet would comprise of 1024, which would be the value of the reference frequency divider data. And they give you the value in the example. Number of divisions, 10.24 divided by 5 kilohertz is 2048, which would give you the 5 kilohertz steps, versus 1024, which would be the 10 kilohertz steps, which would be in hex 800H. Or no, 800, I'm sorry, just 800. And so that would be those. Now these other bits that you have in here, you have PL, PH. That's, I forget what those are. Oh, those are PLL. Those are to turn on and off the PLL. And obviously you have to set PL, PH, and PD pin control. 0 and 0 is PLL operation. So you would have to set those to zeros. The two here at bits 16 and 17 of the packet, remember from the least significant bit, are don't care bits, and then you have LD0 and LD1. That is to detect. That is for the lock detect function. So there's several ways to set that lock detect on the preceding page. Both the 0 on when unlocked, or 0 and 1, which is air pulse output. 1 and 0 is a forced on, 1 and 1 is a forced off. So we got a low or a high state you can set the lock detect line to. So you can just set the line irrespective of whether or not the PLL is locked, which could be handy for troubleshooting, incidentally, because you could just send your packet and just say, well, force the lock detect on, and do exactly that. The next ones are, of course, don't cares, and then the ID bits. Those tell it, and those are the two most significant bits on this. You probably could. I would think. So, you're for a radio like this, you're sending the reference divider is not going to change. It's going to be a straight 1024. For the 10 kilohertz steps. I'm sending this quite literally. The values 1, 2, 3, 4, 5. I think. No, I'm not. I'd have to look at the code again. No, I'm thinking of the other PLL. No, on this one you actually have to do a little bit of math to figure out the data sheet is on, believe it or not, DigiKey. You can take a peek. They used to sell these parts. Now they're new old stock out of China, but they are not on Obtainium. In fact, I got a whole bag of them. Because I wanted to experiment with them. I've got two radios that use the PLL. I've got this, and I've got a Rat Shack radio that use the same PLL. The same rules apply to both of them. This VCO runs at around 16 megahertz. The loop in this radio is running like, there's no down mix or anything like that. It is running. This PLL is capable of running up to, I think, 100 megahertz or something like that. So there's no down mix or anything like that. It's just straight. What is the top speed of the PLL? Some of them have a limitation on how fast they can go. I thought it was here in the specifications, maximum frequency. Operation possible up to 80 megahertz. And that is at 2.5 volts. So, yeah, it is actually a really nice PLL. It take up to 7 volts. So it's 1 volt below, like, the 8 volt rail on a a typical 8719 radio, which is one of the reasons why I considered maybe using this in a 148, and that's only because you can control this because you have a 16-bit counter. This is essentially your 16-bit divider, and you have a 14-bit reference. So you have the space in the chip to do some really cool stuff. Oh, I didn't see Scott up there. Howdy, Scott. You have a lot of room to fiddle with this. You know, the problem is that the radio is, you know, my whole thing is, if I was going to fool around with this radio, like seriously, and I had considered this, man, that gets hot. I tell you what. I mean, 44, 45C, 44.7, man, it gets hot. It's crazy how hot this gets. I cannot believe they made a radio that gets that blasted hot. And I've noticed that. All these radios, they get that hot on the side. It's nuts. They should really figure out that 8-volt regulator, because I suspect that that's what that guy is right there, because this all runs on 8 volts, except for that PLL. Let's see, the schematic of the PLL. Their example of the PLL, their loop filter is very simple. It's literally some resistors in a cap. I think in fact, the reference design here in the data sheet is exactly what they're using in this radio. They just took this reference circuit and stuffed it in there. They didn't show the VCO portion of it, but the loop filter, I'm fairly certain it is exactly the same circuit. So, let's see, I can't remember what the T-P pin is. TPD and T-P. P-T, yeah, because you got P and you have R, or T and R. You have P-R, F-R, F-T, P-T. F-T and F-R, that's the input. TPD is the phase comparator output, so that's your output for your VCO voltage. So anyways, the loop frequency, which is what I was actually going to look at, like, I'm fairly certain this thing is running with no down mix. You hear a little guy in there, he outside there. He's being a little cheerful tonight. All right, so let's see. FT, which is pin 11, is, if I can get it there, too small to see. We're running at 16.85 megahertz. So yes, it is running at the VCO's frequency. So overall, doing it that way makes the VCO in this very simple. It's not like the 8719 radios where they mix it down and then they feed it in, and the loop was running at a frequency. And this is a simpler design. So, you know, simpler obviously is easier to work out what's going on. So, anyway, that's basically it. So, can you do it? Yeah. Is it practical? No. What I would do with a radio like this, if it were me, and if you guys, any of you guys actually really, really want to try it, or take it upon yourselves to do it, I'd love to see someone do it. Take this board out, put it in your own custom enclosure with your own custom display. You got all the data coming up this ribbon. All the stuff that's going into the onboard. There is an onboard up here, A to D converter, and I believe the chip has DAX. No. It has an onboard a DAC, I think, separately. It has A to D converters in the micro, or comparators or something. You know, and that would obviously be for the S meter and all that wonderful stuff. So I'd like to see somebody take this, put it in their own custom enclosure, take this board, work it all out, fix this power supply regulation, just horseshit that Uniden designed. This is just ridiculous. I mean, that is ridiculous right there. I mean, is it that regulator? Man, they are running that regulator at close to red line. 47, 46. See? I mean, they're running that regulator close to red line. It ain't there, but it's close. That's crazy. I wonder what all they're running on that. I'm fairly certain that's 8 volt. I can't see it because it's got that finger over it, but you measure it. I mean, they got some big beefy tracks running from it. I mean, the case where it's at, 32C. The heatsink that's on the other side is 37C. So there's a difference between the aluminum heatsink that's there and the metal that the aluminum is screwed to. So, you know, there's definitely heat going away from it, but wow. That's really high. One thing that I can think of right off the top of my, yeah, I know it. It's just, I don't know what their thought process was with this, because every YouTube video I've seen of somebody who does like 858, these 980s, where they soup them up and they do all that, they go in and they mod this whole arrangement a little bit because it gets too hot. I mean, it's too hot. They're running this. What I suspect is a like a 7808 or something close to red line. I mean, they're 10 degrees away from it just going into thermal shutdown. And the radio works fine. And I've got another one that did. Well, there you go. The only problem is the crystals over here. So crystals is another thing. This has a 10.695, I believe. 10.6975 megahertz crystal, and I think this is I had to look these up because I had to put them into the formula. This is a 10.2417, I believe. My little short ground wire came out. So, yeah. I haven't done anything to this radio as far as, you know, I haven't done anything to them. Like, no cans, I've turned no cans, I haven't unlocked the clarifier, I haven't done any of that stuff. So, the radio is remarkably good on frequency. How far out did I say these things were? Like 3 hertz or something like that. So let's send it some data. 27554988. So 12 hertz. Oh shucks, you know. Let's go put it down in CB or close to CB. 26794988. Its radio is fairly stable. This, of course, is cool as a cucumber because I haven't been transmitting on it or anything. But it's a completely stock radio. So is the other one that I got here that's actually never been taken out of the box because I got a second one. No, I did take it out. That's right. I took it out and I pulled the EEPROM because when I was screwing around with this one, I needed the EEPROM data because I corrupted it, jacking around on the bus. And I pulled it out, pulled the faceplate off, pulled the EEPROM, copied the contents into another EEPROM, soldered it in it. Then I put that one back in the box. So, no, it's been taken out. It's just never been, nothing else has been done with it. I forgot about the EEPROM bit because I was screwing around with it and I got this thing to trigger an electronic countermeasure and, you know, go nuts on me. So, because that's what it will do. They are the micro is monitoring the bus. So if you do anything funky, it will shut it down, or it will try to shut it down. It's probably an FCC thing. I wouldn't be surprised. So, and of course there's no documentation on this thing. There's the FCC actually has the documentation. It's been sealed, so you can't go into onto the FCC database and pull the. You can pull the test data, where the radio was tested for emissions and so on and so forth, but that you can't get any other data from it. And they clearly have the schematics and the alignment instructions and all that, because they had to provide that to the FCC in order to get this accepted for part 95 section D operation. So they had to go through the the stuff to get a certification for this. So anyways, hope that puts some of this 998 stuff or 980 stuff to rest, because there seems to be a lot about. Somebody sent me some stuff on some forums, and supposedly the hack is changing the crystal. That's rubbish. Anybody can change crystals. If you have to change the crystal, I just don't think this radio is really worth it. I know it's a decent little radio, but this side getting too hot, and the poor design decision they clearly made by having a regulator that's taking 13-ish, 14 volts, dropping it down to 8, and not trying to soak up the heat some way else. Anyway, so that's that. I got something in a box that I'll pull out and find out what it is, because I don't remember what it is. But if people want to see more on it, right, and I already have tried to look for anything I could on this. There's no, it doesn't exist. It just doesn't exist. So it would be nice, because it would be easier to hack at this, and I would totally, that's what I mean. It's not that great of a radio, It's just not that great of a radio to try to do anything with, which is why I pretty much stopped. It's just like, I mean, what am I going to gain? I can talk to the PLL. Basically, I can talk to it. I can set it. I can make it go anywhere I want. Roughly 2 megahertz range. So you can do it. I could probably adjust the VCO, get it in 10 meters solid. Do what? Turn it into a 10 meter radio? Yeah, I could. The display isn't going to match where we are, and that's kind of the whole issue with it. It's, somebody on one of those forums that I got sent had the idea right. Go buy a Grant 2, or something like that. They had the right idea. Just go get a Grant 2 and move on. I think that's probably the right way to deal with it. So, this radio is extraordinarily popular. I mean, it is. It is extraordinarily popular. The videos I've done on the 980 SSB, when I look at my YouTube statistics, they are the videos with by far the most views. This radio is far and wide extraordinarily popular. It's just, like Mike said, mediocre. It's stock and it's mediocre. Can stuff be done to it? Maybe, but yeah, 148 exactly. Exactly. Or the Texas Ranger equivalent, to the 148. That's the Ranger, 148F, stuff like that. Those are the radios I think you should target. All right, so where's this box? Sitting over here where the boxes belong. All righty. Here we go. So, inside of this box is a mystery item, because I don't remember what it is. It's actually been sitting there for like a week. Pull the speaker. No, let's not pull the speaker and put an amplifier in it. It's already got enough of a heater inside of it. Let's put another heater in it. Yeah, that sounds like a fantastic idea. Yeah. Okay. Is it a 148? It looks like a 148. It looks like a 148. It looks like a 148. It's not a 148. Oh! I know what this is now. It's the realistic kind of 148 clone. The TRC 450 with a stuck meter. Wonderful. Okay, so there's our clarifier, our RF gain, squelch, and the dim. Oh, the dim is in the inside track. There's the squelch. And our volume on, and yeah. Yeah, I've seen the... This is, yeah, this is like a sort of 148 clone radio. And it's in actually really good shape. I mean, it actually looks like it's in pretty good shape. So, I thought it was an 8719 single conversion. I'm just going to take it apart. Screw trying to turn it on. That's no fun. I don't like to turn stuff on. I just like to take them apart. But yeah, I thought this was an 8719 single conversion variant, like a Uniden Washington, or I think a Cobra 140, or this may be the equivalent to like the Cobra 140 or something like that. I think it's a 140. We'll find out. I got different screws in the back versus the side, so someone may have screwdrivered this. Let's lift the skirt on it. Yes, this looks like the single conversion board. I think this is the single conversion. Oh, 8734. MB8734. It's not even... Yeah. MB8734. What's up with this transformer over here? Is this a filter? No, it's an actual transformer. Huh. That's odd or interesting. Yeah, I think this is a single conversion radio. Yeah, see, it has the coax on the top side, it's on the bottom. I think this is a single conversion. 2SC 1969, 2SC 1306, final drive repair. It doesn't look like anybody's actually ever really screwdrivered this, even though it had a different screw. I don't think anybody's actually... It's got that horrible glue in it, just like everything else. But it's got that dark, that really dark board, that dark colored board. See if I can't find the board number. Around here somewhere. PC... PC 622 Alpha Beta. Never been recapped. I don't think this radio's really been gone into. In fact, nothing's really obvious except for we've got that glue in there that I see it's corroded some stuff down in there. Yeah. Yeah, I see corrosion from glue. Yes, folks, they used glue in these too. Yeah, there's definitely glue corrosion. That sucks. I'm going to have to scrape all that glue out. And there's some over there. Now, that stuff is, in this radio, I bet it's conductive. I've been telling people it's conductive, and people generally don't believe me. No, it's not conductive. It just causes corrosion. And every time I go to measure it, it never measures for me. Yeah, see, like it's just not going to do it. There you go, a little bit. If you get the probes close enough, it's definitely conductive, highly resistive. Is really the issue. You know, you can get it if you get the probes in the right place. Yeah, you can maybe get it, but it's still shit. It's still shit. Just get rid of the glue. So I guess we can look on the other side and see if there's been any soldering, because I can see where the screws have been removed, but at first glance in the top or on the component side, I don't see where this radio is. It's very clean, you know? It's a very clean radio. You still see it even shiny. Yeah, the glue has to come out. It has to come out. So, just get these last screws out and see if there's been any soldering done to the radio. Ooh, look at all the glue. Ooh. Man, they really did a number on, look at the bodges. Look at all the factory bodges. Wow. Wow, look at all the factory bodges. Look at all the glue. Look at all the glue. Woo! Oh man, that is a lot of glue. Alright, so let's see if we can get that so there's some semblance of it being yeah, see, it's not going to do it for me. It's totally not going to do it for me. I swear this crap is conductive though. Yeah, this is bad. I mean, they glued. Look at it. I mean, it looks like the little guy who went crazy with the glue gun. It's like he sprayed it over here, and then you could see a line of it that comes down, and then it goes over here, and then there's a little dribbles in a couple spots that come over here, and then over here. It's like he went whoop 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 whoop. I mean, with the thing. I mean, jeez, man, he really glued this thing to bits. Of course, this PLL's never been soldered on, so I don't think anything in this radio has been soldered on. In fact, I mean, I don't think anything's been done. This bodge over here is interesting. We got cap, resistor, well, two cap, a diode. I wonder what that mod there is. I wonder what this mod is. But yeah, it still has flux residue all over it. These outputs, I don't think they've ever been changed either. I don't see where anything's actually ever been done to this radio. I'm just wondering why this coil looks like it's been mushed a little bit, but you know, I can straighten it up like that, and now it's, you know, more or less okay. That could even been a factory oopsie, you know, that it was just sort of pushed over. That could have even been a factory oops. So that wasn't like a tweak. You know, this one's also been a little mushed over, you know, with that component. So I think those are like factory oopses during assembly. But you know, these things are all still Loctited. Looks like the original Loctite. I don't think anybody has been in this. This may very well be a fairly virgin radio, which is rather uncommon to find. Yes, it was an untested radio. Yeah, it was an untested radio. So I guess I should probably turn it on and see if it even works. I'm a little hesitant to, because usually when I see something like this, I'm thinking that I'm going to get popcorn out of it. You know, like I'm going to get all the capacitors are just going to explode in my face. And they don't have vents, which means they shoot off the leads. You know, the leads they shoot right off the leads. You know, that was how these old caps went up. You know. Well, it turns on. I don't see any issue with the channel selector. It's not wobbly. It's not losing digits, anything kind of funky, you know. The meter is stuck, but that's just like, you know, get in there, loosen up the screw just a little bit. The meter is totally fixable on this. Unless somebody's gotten into it. If somebody's gotten into it, then, you know, and I don't think anybody's gotten into it. Is the tape still on it? No, it's not even sealed shut. I can actually get to the screw. Because all you got to do with that is get on that screw just a little bit. See if you can maybe break it loose. But it's got the glue on it, so I probably got to get the glue off first. Yeah, I got to get the glue off first because it's Loctited down. I think it's usually some acetone or something. I actually have nail polish remover. I get a little bit of that on the tip of the screwdriver and put it down in there. Cause that stuff to bubble up, and you know, it'll loosen that up in a few minutes, and that is actually. The meter is, yeah, that is actually the top one, because this meter is one of them. It's flipped around. Yeah, I actually just get nail polish remover. I've got the, let me see what brand this is. This is the Top Care nail polish remover. It's protein enriched for natural nails. You see, this way we can get our natural nails you know, going on with the screw in there. we have some natural, you know, easy stuff. Yeah, see, that stuff is pretty much getting all gummy, which is what you want. That stuff starts getting gummy, and then it'll loosen up, and then you can turn the screw. Once you turn the screw, you only got to turn it just a little bit, and then it'll just free right up. Still won't. No. Still won't turn. But that's okay. You can get a little bit more on it and keep trying to wiggle it loose. That one seems like it doesn't want to budge, incidentally. I don't think this one wants to budge. But that's okay. We'll get the rest of that. You can see it coming off on this. Maybe see it coming off on the screwdriver a little bit. It's loosening it up. Yeah. Yeah, it's getting all gummy, so it'll free up here in a few minutes. It just looks a little thick on here. So, and it's like blue in color. It'll loosen up. If not, then maybe a little bit more force is required. But anyway, so do I have a 5-pin microphone? It's one of the things I don't have a lot of microphones. Every time I think I'm going to go buy a lot of microphones, I don't do it. So do I have a 5-pin microphone that isn't like completely destroyed? Because I only have one and it's destroyed. I don't get too many Crack Shack radios. No. No. Huh. I guess I don't have a 5-pin DIN microphone other than the destroyed Crack Shack one that I've got here. So, and what I mean by the destroyed one is this one that's destroyed. It works. It's just the case is destroyed. Hello. Let's see. Are we on CB? Oh, it doesn't work. Hello, the modulation light comes on. Hello. Let's make sure that's all the way in. Hello, hello, hello. And there's no output. Nope, we got no output, folks. Nada. Well, that's... Hello, no sideband output either. Hello, 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 hello. Nope. Hello, the mod light works. The little mod deal. You know, hello, hello, hello. The mod light works, but no output. It's probably all this glue. So, it's probably not even worth trying to figure out what it is, because I'm probably going to find out it's this glue and capacitors that's the reason it doesn't transmit. Nothing getting hot in the sides, nothing getting hot in the back. It's just no output. It's just one of those deals. See if that microphone's loosened up. If not, maybe it is the other side. You know, if it is the other side, then so be it. Nope, it's loosened up. Yeah, it's loosened up, so. There we go. The meter has fallen, and you can shake it. Yay! Yeah, it's on. It's dim. Well, it has a dimmer. Yeah, it has a dimmer. Squelch, RF gain. Noise blanker A&L is on this. I didn't realize that until just now. You actually have to pull that out to get the noise blanker. They should have left it in for the noise blanker. That's kind of bass-backwards. I would have rather pulled it out to turn it off, because you're going to leave it on, and then what's going to happen is, oh, I want to turn the RF gain, and you're going to push the control in. Hello. Yeah, see, there's no output. Hello. I can see the needle moving. You know, when... Yeah, needle just falls. So, anyway. It probably just... Wow. Here you go. Here's a good one. You see this plate? That lines up with all of this, all these spots, line up with all the glue, where all the glue is. I mean, that is a dead, it lines straight up with that. It's just, wow, perfect. And the spots, you know, that you see there are where the capacitors were. Like this one, and these two, like that one, these polydip deals. You could see where they were close to the cabinet, and so the outgassing of the glue, I'm telling you, this glue's nasty, and this is actually a perfect illustration of it, because you could see that it actually stained the cover. I've actually never seen that before. But yeah, that's a dead giveaway. That is exactly the same places and patterns as the glue. So that's really interesting. Huh. So yeah, it doesn't transmit. I guess I could look to see if it's like a, you know, output kind of a problem by just going up here and seeing if we're getting RF up here. If we're getting RF up there, then it's probably outputs. If we're not, then it's, you know, further back kind of thing. But let's just see. What do we get there? Hello. We got nothing. So yeah, there's nothing there. Or is there? Hello. No, there's just nothing. There's just nothing there. You know, how about VCO? It's an 8719 radio, so let's see. VCO, that's going to be... VCO's working. Yeah, VCO's working. It's on frequency. Yeah, channel 20 is 35005 VCO. Yeah, it's dead on. Yeah, so VCO is working. It probably does. It just doesn't transmit. It's just goop. It's just been gooped. Fire up a signal generator. Yeah, there's no output. Yeah, I mean the goop over here has probably shorted the thing out, so let's see. RF dB carrier 27.205 megahertz. See the needle moving. I'll turn off the carrier on the generator. Boop. Yeah. So it receives. The signal generator is just throwing a rubber ducky in it. It's just throwing it out in the air. Yeah, it's receiving. Let's see, it says AM. We want modulation. I don't know what I did with my external speaker. It's around here somewhere. I just don't know what I did with it. I cleaned up earlier and I still didn't see it. So that's unfortunate because I tend to use that a lot. And so to confirm receive audio, I'm going to have to plug this one in real quick. Let me just make sure that volume's down. I don't need to get blown out of the room. Jeez. So yes, it is working. Anyway, the control's dirty, so that's why it's sort of. Yeah, I'm thinking this is just a recap. This is a recap and clean glue, and it'll probably be fine. Because the only other thing I can think of that would prevent us from having RF would be, that's VCO. This should be 7.8 in, which is nothing. There's no 7.8 in, and that's unfortunately important. That's why you don't get any transmit. So it's probably getting lost up here. We got all this glue in here, and this is where it goes into the mixer. It's, yeah, you know. Yeah, see, there's just no output from the mixer. But, no, I don't have any signal coming even out of the mixer. It's got VCO going into the mixer. It doesn't have 7.8 going into the mixer. So it's missing one of the components for the mixer at the mixer. There's just nothing, no 7.8 at the mixer. But I got the 35 at the mixer, so it's probably, you know, yeah, there's just, who knows? It's just glue. It just needs to be cleaned up real good. And the thing about this radio, it's actually in really good nick. I mean, there's a little bulge here in the metal piece right here by the channel selector. They probably have voltage. There's just no RF getting through the mixer. It's before the mixer, so yeah, it's just 13 volts. If I transmit, it shouldn't like sag. It should go down to whatever AM. You know, the AM voltage is like 5 or 6 volts or something like that. Yeah, 6 volts. It's fine. There they are right there. Right around where that glue is. So I'm kind of wondering. I've seen these trimmer caps get so corroded over the years that they actually, you have to turn them to sort of get them. They get tin whiskers or something and they short out. I've seen stuff like that because this is an old radio. They are not oscillating. That one is. That's the lower sideband. So if the lower sideband is working, I bet that probably the radio... Hello? The radio does work on lower sideband. Hello? Yeah, I have output on lower sideband. Hello, hello, hello. I have no power on AM and upper sideband. That is the other crystal for AM and upper sideband. That's why I've got no 7.8 megahertz there. So it is this crystal with the glue, incidentally. Perfect example of the glue causing a problem. This is exactly it. Exactly the issue with glue. I know it's the glue. One crystal on lower sideband. So you have TRC-450. Lower sideband works, upper sideband and AM do not work, and they share the other crystal. So that is exactly the issue. It's not oscillating. The other one that's lower sideband, that one good strong 7.795. Yeah. I'm not sure what a good cleaner is. I've tried a few. Like this is IPA. I could try to get in here with IPA and see if I can. Well, I can go back over it if you wanna see. No, I talked about how the SSB980 more or less is not really feasible for a channel mod. I've got some people sent me some links to some forum posts where the 980 SSB discussions have been revived, and unfortunately I had to debunk it as possible but not practical again. That's the issue with them. Possible, not practical. Yeah, this doesn't seem to be really taking it off. Maybe I'll let it sit there and soak for a bit. Well, I already have effectively modified it. It's just, you know, who wants the radio's display to be useless? You know? Okay, so you can get the channels, but nothing on the front of the radio is, you know, it's not worth it, you know? Actually, ooh, oh boy. I think I see Houston, we have a problem. Ooh, we have circuit trace damage right here. No doubt caused by the glue. I'm sorry, what's the... I don't honestly know. I think we would have to put one of those on a signal generator with a, or a spectrum analyzer with a tracking generator to figure that out. Yeah, these tracks over here that have been glued, I think this has just been damaged. I'm not having any luck getting this glue off with IPA. Yeah, I can see the track has been corroded. It's not gone, but you can see that the glue has permeated through the solder mask, and I could see it has that distinctive discoloration where it's gotten under the solder mask, and you can see it. So, yeah, it's that kind of an issue. Yeah, he wants to know what the filter bandwidth is on the 980. We'd have to pull a filter out and put it on a spectrum analyzer or a tracking gen and see what its effective bandwidth is. It has one of those big, you know, crystal filter, you know, boxes in it, so it's probably okay. You know, it's probably okay. I never really was, you know, I've used the 980 to listen. I've never thought the receiver was, you know, lacking. I always thought the transmitter was for shit, though. But, you know, I don't think that's going to. Some of the glue is gone, but I'm not sure what really gets that glue gone. Maybe acetone. Why am I having trouble getting this thing in here? Maybe help to look and see what I'm doing. Hello, no, it's still no oscillation on that crystal. Could be just bad too. That wouldn't be above impossible for it to just be bad, but oh, the glue is getting gummy. Okay. The glue has gotten gummy. No oscillation on that crystal. It could be a dirty switch too. Yeah, I mean, it could be a dirty switch. Hello, we got sideband power. Hello, or lower sideband power, but yeah, probably not going to happen. I did isolate it from the glue, so it shouldn't be causing, the glue shouldn't be causing it a problem now. We probably need to see if we have any kind of voltage on the crystal, because that would indicate like the you know, yeah, see, that's the one. And well, wait a minute. Oh, it's right there. Yeah. So I was actually loosening the gunk up on the wrong set of tracks. Yeah, I think the glue's starting to come off from the IPA. Usually I just get in there and try to scrape it out. Hey, it's Buddy. Yeah, look at what I got here. It's funny you say that. I got glue in this radio, and I think it's killed the one of the oscillators. Well, it's not working, so you know. Yeah, I can see bare copper where the glue has completely corroded away the solder mask. So yeah, I'm just not surprised by that. I just see bare copper. So so I got no AM power. The crystal could be bad too, you know. That wouldn't be above impossible, you know. It could just be bad. It could be that the lead's corroded off the crystal too. So what I can do is, ooh, you know what? I'm betting the lead's corroded off that crystal. I'm betting the lead's corroded off of it. Yeah, I think the lead's probably corroded right off the crystal. I see the glue in between the crystals going down to the board. Yeah. I'm thinking the lead's just gone. There's no lead on the crystal anymore. The lead just went into the... the lead just went... I just sucked the lead up. I just sucked the lead right off the board. It just... Yeah. There you go. Yeah. Oh, well, I got to get the other... Yeah, the lead. I just sucked the lead right out, right off the board. Yeah, that's it, right? That's the issue right there. The lead just sucked right off the board. Ooh. Okay. Yeah, it's just... Yeah, it's just... I don't know if I can get a good picture of this. I'm gonna try. Yeah, you see where it ate the lead right off. So that's why we don't have any AM or upper sideband. 7.8025 megahertz crystal is kaput. That's it. And I do not have one of those. So much for that. So, ooh, there's a diode in between them. And the diode looks really bad. You have an Ungar, huh? That diode looks finished. I think it says 97. It's probably D97. I think that diode's finished. I don't know if there's anything on that crystal to really salvage. It looks like the lead has been compromised right up into the package. So I don't think I can... I don't even think I can get anything... Yeah, it's like level with the case, you know? I don't think that there's any way to... it's like one of the bottom of it's ceramic. Yeah, I don't think that that's anything that can really be bodged really quick like for a... I don't think so. Yeah, I don't think so. But they get my 30-year-old alligator clip thing. Drill it. Yeah, I think it's probably just finished. It needs a crystal. I can get one probably out of the old Washingtons that are here. You know, I got one of them that's sort of parts. If I could get a little ball on there, I could probably get some, you know, get a little bit of lead to stick to it and probably stuff it in and see that it works. But there's not enough lead there. Yeah, there's not enough. Now there is another way to bodge it, and that's to try to crack open that cam. But it's time for another crystal. That's the problem with the glue. If you have this glue in your radio, get it out, because that's what happens. Let's see. C79 right in front of FT1. It's an electrolytic. I see it. 47 microfarad at 10 volts. 47 microfarad at 10 volts. I think, yeah, 79. Yeah, 47 microfarads. That's what I've got there. That's what's in this. So, well, it works on lower sideband. 0.1 polycap? Really? Oh, is this an 8719 Washington? Yes, it is. All right, so this is a working Washington. I always borrow the cap for test purposes. And these have not been glued, I don't think. No, it's a electrolytic. 47 at 10 volts. But the footprint, I can tell you right now, the footprint does not look like a... it's not an electrolytic capacitor's footprint. It's a polycap's footprint. Yeah, it's like one of these dipped poly capacitors. That's the footprint. The silk screen on the board does not match what's there and what's there. You're right. So something changed at some point, yes. I would have never really thought about that. In fact, if I pulled that cap out, I probably would have looked at that and said, wait a minute. You know, when I went to go put another one in, because I would have been looking like, okay, what's the symbol? You know. Now on this board, it looks like the silk screen matches on this board. Do I know why they changed it? Well, it's part of the balanced modulator circuit. So I honestly couldn't tell you without like looking at the diagram. It's part of the balanced modulator. So, So anyways, yeah, we had a broken radio. I know what's wrong with it. It needs a crystal. Once it gets a crystal, it will probably be fine. But it needs to be, you know, glued or deglued, and yeah. In fact, it looks like that cap's got the guts coming out of it. Oh no, that's just the glue. That component is destroyed. That's yep. In fact, I just snapped the lead right off of it. That's a diode. Huh. That's a diode. It just snapped. I just snapped the lead right off of it by just touching it. It just broke right off. Yeah. So I just killed another part in it. And it doesn't look like it was a part. It looks like it's a bodge part too. Okay, so that's C107, and this is clearly a diode here. Like a 4148. There's a jumper wire next to it. This is all green down in here, nasty. Yeah, it's all green and nasty and everything else where the glue and whatnot is. Yeah, this is pretty bad. So this is one of those restoration candidates, and it's a good shape, the radio, so I'm probably going to restore this radio actually. Yeah, it is leaking. It's just this cap down here is leaking. But it's in good shape otherwise. Like the board is clean otherwise. You know, we've just got corroded parts. Now this down in here where it's sort of eaten at the the solder mask is a problem, because see, as I get rid of the glue, it takes away the bit of the solder mask, and you end up with exposed copper like that, which I don't think you can probably not see it. You probably see the shiny bit in there. That's the exposed copper because of the glue that has eaten the solder mask off. So yeah, it needs a glue removal. It needs a cap. Or it needs every cap in the radio. It needs a diode down in there that's probably a 4148. This diode in here next to the crystals is probably completely destroyed as well. Yeah. Yeah, it's gonna break as soon as I try to pry it off the other capacitor. It's just gonna, or the crystal. It's just gonna break. Other than that, radio looks like it's in pretty good shape. So, yeah, I mean, this is all right. I can't complain. And the other thing I was thinking about is, can I put a channel mod in here? Well, I absolutely can, because it's got an 8734 in it. So This is a radio that originally came with an 8734, and I wouldn't even need that PLL chip. You know, I just end up pulling it out. 8734 with a date code of 35th week, 1979. The mixer has a date code of 44th week of 79. So I think that kind of dates the radio here a little bit. It's definitely a very early 1980s vintage radio. Probably is from 1980. I don't know how to decode serial numbers for Rat Shack radios, but this one is serial number 03005768. So, wonder if the output transistors have a date code on them. Nope, just a type. So, and that one, 1306, it does have an original 1306 in it, so that kind of dates it as well. It's got the Uniden UHIC070, the brown colored VCO block, and all the coils, all the variable inductors are Tocos. The MB3756 has a date code of 48th week, 1979. So, yeah, if that's actually going to be the newest part, 48th week, 79, 35th week, 44th week, 48th week. It's going to be this is going to be a 1980 radio, probably right on the nose, 1980. So, even got a little bit of green in here from the speaker lead that's even a little corroded. But yeah, I think I'm going to restore this. It has a nice channel selector. I kind of like this channel selector, but unfortunately, if I do my thing, it's not going to have that channel selector anymore. I like the knob, really, I guess is what I'm thinking about. Because you can get on an encoder, you can get a real good spin on that. Just run your finger around. 1980, I figured it had to be because of the date codes on all the semiconductors. It just matched. So, yeah, 1980s radio, or 1980 radio. So, it's an interesting cap to be bodged the way it is. It's a factory mod for sure. It's an interesting one. Oh yeah, it's just a D shaft. Yeah, it's just a D shaft. This is a D shaft right here. You know, I mean, fairly standard encoder. So, yeah. I'm throwing that away for. I want to put the knob back on the radio. Yeah, I think I'm going to restore this one, and I might actually make this one my new car. My car one that I put out in the car. I think that's what I'm going to do with this one, because it's a really good shape. I'll probably swap it out for the Grant, and go with that. So I'm just going to look at something right quick here while I'm thinking about it, to see if we got any movement on something here. Some people might know what I'm talking about. Yeah. Maybe, I don't know. I'll have to see in the morning. Oh no, I probably did say I couldn't keep it, and I was wrong. I was like, I can't keep the encoder. I can keep the knob, because if I do my thing, I'm gonna take the encoder and the whole channel selector and thing out. Now the display and the channel selector are separate because we've got this interesting whole board going on over here. Yeah, sorry about the confusion. Yeah, I can keep the knob. I just can't keep the control. But in order to use one of these encoders, you only need like the 3 bits on it, to determine which way you're going. You only need 3 bits. It's not a particularly difficult concept to use this channel selector in place of an encoder. You just don't have a button now, and that's kind of the only thing. So now there's no button, and what to do at that point. So yeah, it's one of those deals. But yeah, I'd be fine using this radio. I think I could definitely. I'm wondering about that encoder. Is that even the right length? Because I can see that this has a different bracket on it for most radio. I like encoders more. That's just me. It's a preference. This is the correct encoder. The correct length, shaft length. I'm just eyeballing it, just based on that, and yeah, it's exactly the right length. So I couldn't use the shorter encoders in this radio. Like here's a shorter encoder. So I couldn't use this one. This one would most decidedly not reach. So, but yes, encoders. Yeah, I'm not a fan of the channel selectors. That's just me. I like the fact that I could sit here and do something like this and spin. That's kind of why I like this knob. You can do it with the Grant. You just, put your finger on the top of it, and yeah, it's a 37-year-old radio. As many times as I tell people that, I don't know why people are insistent that encoders are like the devil. The specs on these wafer switches, because that's what these are. These are wafer switches. They aren't that great. They probably only had 50,000, 75,000 rotations between failure before these things would start to fail. Encoders are up in the hundreds of thousands of rotations, and that's for cheap encoders. I'm talking about the 50-cent encoders, But yeah, I've heard people say that encoders are the devil. Yes. This will fail, and it's unobtainium unless you get a donor radio. It's just, I'm not a fan. So, yeah. The 980 SSB encoder compared to one of these, I think the 980 SSB encoder is midday nap. Well, good on you, Peter. I probably should have taken a midday nap, but I didn't. So, I'm here looking at a 38-year-old radio, 37-year-old radio that is, for all intents and purposes, looks like a virgin to me. $269. Now, Mike has got the conversion on that one. If this cost $269 in 1980, this probably cost, in today's dollars, this is probably a $1,000 radio. Easy. I would be willing to bet this is a $1,000 radio. We could probably Google that really quick. $269. And 19. I don't know what I'm looking for. Yeah, so I wouldn't be surprised. Inflation calculator. 269, 1980 to it goes to 2016, but that'd be interesting. $829.53 according to that. This is a realistic TRC 450. It looks like an 8719-ish single conversion variant. So the predecessors to like your 148s, board looks identical to like what would be in a Washington. Has an 8734 PLL chip in it. But yeah, $800, $900 for this in today's money. So if I look at this and say, well, this is an $829 radio, I think it's worth fixing it. I really do. It's worth fixing it just for the problems it has. It needs glue removed. It needs a crystal. It needs a diode, probably 2 diodes so far. It's probably worth repairing. Totally. It's and the faceplate's in great shape, and the covers are actually in pretty good shape. They're not too, they're not like scratched up, and like those are the covers. It's in good shape. The radio is in really good shape. It's just got a glue problem. All this glue's got to get scraped out. And 451. I'm guessing the 451 looks like this. Is it a sideband radio? Yes, that's true. They wash. Well, wait a minute now. I'm not entirely sure that's accurate, that they wash both through the same filter. I don't think they do. 2824 is in the PLL. TRC 451. Realistic TRC 451 CB tricks. There's a schematic of it. No, I think this was cheap. I want to say this was like, I don't know, I think I paid like $30 for it. Something like that. It was a pretty good price, I just saw, realistic sideband radio, older variety. Yeah, it's got the 2824. Maybe I should look for a TRC 451 on eBay, because I haven't been looking for those. Because I would get one if it's a sideband radio. Is it a sideband radio? TRC 451. Yeah, it looks almost exactly the same. It is a sideband radio. $70, buy it now? Nah, I'm going to pass on that one. But I'll watch it just so that I can remember it later. Yeah, $30, I think. Yeah, I look for bargains like this. And this is what I end up with. A radio that's in good physical condition, which is more than I actually bargained for. That's basically a earlier 8719 FT2. On this radio, it's right here, and it's actually flat. Yeah, It's level. I mean, it's all the way down. It doesn't look like anybody pushed it out. That's a good question. Why would it be all the way out? I know what you're talking about. I think I've seen that before. So, yeah, the basic thing with this is clean the glue out, pull the caps off. That's what I was going to try. I was going to try to see if this acetone would take this glue off easier than IPA. So, does the acetone kill the glue better and quicker? That is what I'm about to find out. Because don't think I've really tried it. I can't recall trying it before on this to see if it looks like it's actually taken this glue completely away, the acetone. So that might be the preferred way of getting rid of this glue. Because I hate scraping at it, you know. I don't want to scrape it off. I don't want to scrape what's under the glue apart, you know. I used to use that stuff many years ago. I just ran out of it and never got any more. Should probably just go ahead and get it again. But yeah, all the GC electronic stuff. Like I've got the liquid flux. I used to use that stuff, but I don't think I ever used it on this glue. It may have been a glue like this. This brush is actually falling completely to pieces. It's just time to retire that brush. So, here we go. I got another one with long bristles. Yeah. It looks like this acetone is taking the glue down. I can see it discoloring it, you know. So it's probably killing the glue, which is fine. I totally want it to kill the glue. So if I can get a little bit of acetone on this glue and let it sit there for a little bit and eat the glue away, that I can maybe peel it off or wipe it off or whatever, that'd be great. I'd be totally happy with that. You know, because nail polish remover is cheap. It's cheap stuff. So, and it isn't as noxious as like straight up acetone. Like I can go to like the hardware store and buy you know, a gallon of acetone or something like that, which is stuff that I used to do, believe it or not. But yeah, I think it's completely eating this glue away. So let's see what it's doing. Because it looks like the edge of the glue is like lifting up or something. Yeah, it's eating the glue up. Huh, that's cool. That's kind of neat. It's totally softening it up, so that's what you want. Soften up the glue. Oh, it's just breaking apart into little bits. Yeah. I could probably get a good stiff brush now and brush most of this off. So that's good. I'll probably have to get some of the old GC Electronics solvent stuff as well, and you know, just because I used to have some. When it was all gone, I just never got any more. Used to use it for some things in like literally TV repair, you know, but I don't really do. Well, not really. I just don't do anything with like TV repair anymore. Any consumer electronics. So, yeah. Let's see. Nope. Oh, the. Well, if it is, I mean, it's totally eating it off. I mean, it's totally eating the stuff off. So, in fact, it's just turning into goop and getting all in my brush. So, Oh yeah. You could see where it attacked the copper underneath, because it's now the copper is getting exposed where the glue was, and this glue corroded the copper on the board, and now that the glue is essentially coming away, you can see the damaged solder mask. Like in here, I can see the damaged solder mask, and it's yeah, it's unfortunate that it has destroyed the solder mask on the board, but you know, it's kind of, you know, what happens with this old glue. You just have to get rid of it. You just have to get rid of this glue. So I'll get rid of it and we'll be good to go. I'll get this radio back up and running and in good nick again. And then I'll modify it with channels. Anyways, it's gooped up my brush now, so yeah, it's gooped up my brush. So no, I keep I still have some up here that I have some of these sitting up there on the shelf. Yeah. That will be, if I'm going to slur my speech, it's going to be this that causes me to slur my speech. I actually like Crown Royal. That's a beverage of choice. Do I have the other bottle still down here? Oh, I've got some cheap stuff down here in the other liquor cabinet that I've got in here. I've got some cheap stuff. Here you go. You can see how much of this is left. But yes, this is cheap. This is just cheap rubbish. No, that's a different bottle. I've got like 4 bottles up there. I have more bottles. That's not the only bottle. I get them from the... They call them... It's funny because here in the South, they call them the ABC store. See if it'll... I already done all the glue with the acetone. So... No. Yeah, I already did it. I already hit it with the acetone. So I don't want to mix the acetone and the Crown. I want to drink the Crown. I don't want to play the bloody radio. No, I want to drink the Crown. Yeah, that's like totally eating the glue up. That's doing pretty good. It's just eating the glue up, turning it into gum. I could probably go through here in a short while with a good stiff brush and brush it up, make my voice lower. Yeah, right. No. You guys are too much. I'm not going to drink the acetone or anything like that. I'll drink the Crown. I'm not going to drink the acetone. Yeah, it's coming off. Where it's really thick, I think it just needs a little bit more time to penetrate it. But it's coming off. It'll just soak up the acetone, turn into gum, and it'll just come off. And then I can see about the circuit trace damage under here, which it actually did a pretty good job of getting it off of the traces without lifting it up any more of the solder mask. So that's pretty good. I can't really complain there. Over here it looks pretty bad that it took off some of the solder mask over here, and Yeah, but it's yeah, this'll all come up. Oh yeah, really bad right there. Really bad. That's all exposed under there. That's pretty bad. Glue really did a number on corroding the solder mask off the board. That's really sort of a shame, but oh well. Get it off the aluminium. But yeah, it can be. This is totally salvageable. I'll get a crystal from a donor. If I have a donor. I don't think I have a donor. I have to make a donor. I think I want this radio more than I want one of the Washingtons. I got enough Washington, so I'll take it out of the Washington, put it in this. Mod this up really good. I wonder how clean this this faceplate will become. It looks like it just needs a good buff, and it'll be good. I don't see any nicks in it anywhere. I don't feel any nicks anywhere in this thing. It's a little scuff mark up here on the face, but it's not too bad. So, anyways, yeah, tomorrow's project, restore this. So I'll restore it. I'll put caps in it and do all that wonderful stuff. And I'm hoping that I can get something for tomorrow, but I'm still waiting to see if it's going to show up. So if it shows up, then there'll be a treat. But if it doesn't show up, then I'll be disappointed. Yes, I will be disappointed. That will be disappointing, because I really am hoping that that something that I want to do tomorrow happens. So what I will encourage everybody to do is to keep their eyes out tomorrow, because it might be interesting. So good night, you guys that are leaving. Yeah, you can send me pictures, but I don't. Yeah, I didn't look at those pictures on purpose. I kind of want it to be a surprise. I want to be surprised. So I didn't look at them. I just skimmed through them. I mean, yeah, I saw them, but it's hard to not see them, obviously. But you know, I did my best to not really look at them, if you get what I mean. Yeah, it looks like the glue is coming out, so that's good. Just keep, poking at it, and the glue will get off of there. But if the GC's solvent stuff works better on this glue, then I really ought to get some. As many of these things as I've been playing around with. Because in what I normally do, that stuff isn't really necessary. So it's not like I have that stuff around because I need it or use it. I really don't. So, but yeah, oh yeah. In some places the glues come off easy, but it looks like it's come off easy where it's corroded the solder mask. So, or gotten under it. But other than that, in some of the thicker places, I guess it's still working on it. Ooh, yeah. This glue is something else. It's a terror. Now, I'm wondering whose bright idea it was to use this glue, but they probably didn't even know what the long-term effect of using this glue in these radios would be anyway. They just did it and didn't think, well, what'll happen 30 years later? Oh, well, yeah. They'll be antiques. Nobody will be using them. I don't think anybody at Uniden, for that matter, or any of these companies for that matter, probably considered that these radios like this, would be actually sought after. Toothbrush? Yeah, you know. What I usually do is I've got like these horsehair brushes, and I cut the bristles really short, and I guess that kind of allows it to behave like a toothbrush because they're stiff. So, but yeah, a toothbrush, I could see where that would probably work just fine, yeah. These bristles could definitely be shorter. So, that's why I get a scissor and I fix him up over the trash bin. So, I just cut the bristles short, like that. And now they're half the length that they were before. Yeah, that's what I just cut it down, and it gets them really stiff. You know, they won't hurt them. They won't hurt the solder mask or the board, but they're really stiff. So they get, looks like, yeah, that's working pretty good now. Yeah, it just needs to work on that glue some more to get the rest of it loose. But yeah, that's actually working a treat. You know, in some areas that's working a treat where it was thinner. And back here, yeah, it's working pretty good back here. But back here, the board's actually been damaged by the glue. And I've got exposed copper now back here. So, yeah, it's just a matter of cleaning it up. Now, I know that a lot of you guys are like restoring and custom building and stuff like that, and I know a lot of people, they question, ooh, I didn't mean to pour that much. I know a lot of people, I've seen people question, oh, it's so expensive to get the radio with the glue cleaned out. It takes a lot of bloody time. I mean, this is time consuming. And then the board has to be repaired under the glue. You know? Because that's all damaged board under there. Yeah, you could use fingernail polish. You can actually get solder mask. I actually don't know where mine is. I have a bottle of solder mask. And it does have a little brush. And, you know, you can get it in colors, green, so on and so forth. And you get in the area there, you buff out all the old mask. And, you know, once you get out all the old mask, then you put down the new mask and let it dry, and it kind of blends in pretty good, usually. I can't say that I had any issue with the stuff when I used it. It seemed to work fine. Just need to get a little bit more of this acetone down in some spots. I can't really move these bodge parts because, or can I? Is it loose now so that it will move? Okay, they've separated. Okay, there we go. Yeah. Yeah, it's come loose now, so. Well, at least those bodge parts don't look like they were damaged by the glue. Those were inside of a plastic tube. Yeah, I've seen that stuff. Because it's basically what the board house uses. You know, they've got UV sensitive stuff. So they just hit it with the UV light and then poof. That's the end of it. It's just done. So, but yeah, it looks like a lot of this glue is actually coming off. So this is good. It's sort of run down a little bit the side, but that'll be all right. Yeah, board houses use the UV stuff, and it used to be obtainable but really expensive. So I'm sure now it's probably come down in price. I've just never bothered to investigate whether or not you can get it. But yeah, it would make sense that you should be able to get it. I mean, you could get it then. It just wasn't really cost effective to get it. You know, it was expensive, and you were just better off with the stuff that you brushed on and just let dry. So that's what I know a lot of people were using for a while. But if you can get the UV stuff now, cheap, hey, I'll get some of that. Because that stuff would definitely be faster. Because you can get like handheld UV lights and, you know. Oh, if they have them in colors, it's even better. Instead of just like green, you know. Like if they've got, because you could obviously try to match it to the board, that'd be great. If you could get green, or you can get, you know, blue or red or whatever, and match it to the board, that'd be great. So, this is mostly gone, the glue. Mostly gone now. In virtually every spot except for a few stubborn ones. Over here is a stubborn spot. Yeah, this one's really stubborn. Ooh, there's a big blob of glue that was under that part. I didn't lift it up. Yeah, so there's a big piece of glue. Yeah. So this radio will turn out pretty good. Just have to clean the board up real good afterwards and fix these spots. Another thing you can do to repair bad solder mask, the poor man's way, is the exposed copper. Just tin it. If you just tin it, that works good too. That's just a cheap and easy way to do it. Just tin it with solder, and that'll protect it. Obviously, solder mask is superior, but in a pinch, if you didn't have any of the solder mask and you had to get it done, you could totally just tin it. Which is pretty much what I've been doing for the most part for a long time. It's just tinning it. That protects the copper from further damage. So, tinning it works too. But if you got solder mask, use the solder mask. This one's really stubborn over here. So this is a really stubborn spot. This one does not want to come off. It's like really stuck down. Come on. There we go. This is a really stuck spot. There we go. It needed extra persuasion, that spot there. Oh, I see. It was eating away at the tracks, and it was like sticking to mask in the copper and everything. So, yeah, now this just needs to be cleaned up. I think it'll be good to go. Food color. Oh, wow. Did they really use food color on old boards? Because I don't know. You guys probably know a lot more about new boards. I can actually tell you do, but you know more about. A lot of you guys know more about old boards than me. They really use food coloring. That sounds. Oh, tin circuit boards. Yeah. Yes, old boards were just tinned. Yes. Yeah, old boards were just, yes, they were just plain old tin boards. They just tinned them. I've got some around here that are just tinned. You know, and they're old, and yeah, it's just tinned. It works fine. I mean, it works. Those old boards are still around now. The looks like the bristles are starting to fall out of the brush, and that's usually a surefire way that you're about to. You're coming to an end of the use of the brush. And the bristles start falling out of it. That's pretty much the end. And it's time for another brush. Oh yeah. Yeah, the bristles are coming out. Yeah, I got a little pile of bristles. Yeah, that's the end of that brush. Yeah, bristles are coming out. That's bye-bye. I had a whole bag of them. I'm not worried about the brush bristles. Sort of dab some of this acetone up a little bit. See what we got underneath here. Yeah, that's a lot better. So we got corroded tracks here, 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 and here. Oh yeah, the bumpy tracks. Yeah. Those were those tin tracks that they then solder mask over the top. Yeah, I know. That's those wavy boards. Yeah, they looked funny. Ooh, this component that I pulled the plastic off. Ooh, I don't know. It's a resistor, it looks like. But I don't know if I'm going to be able to read the bands of that resistor. Because it was, the glue went into the tube, you know, into the piece of clear plastic. And, yeah, it looks like that resistor is probably kaput. I don't know what the value is. I can't even, no, there's no way I'm going to read the bands on that. It's corroded. So I have to figure out what this is. This bodge component is, because it's been completely corroded. If I get it cleaned up sufficiently, well, I don't even know if I would trust to measure it and see if it was the right value, because if that stuff has gotten into the resistor body, you can forget it. It'll change the value of the resistor, and that's it. Well, yeah, I could measure it, but I don't know if I'd trust the measurement, because if it's gotten into the resistor body, you can forget it. It'll change the value of the component. So then you'll get either a weird-ass value or something that you think it is, and you'll put it in there and it'll still be wrong. So one of them is an orange. I know that much, but the rest, I can't tell the color. They all look white, which I know is wrong. So I'm sure that somewhere, some way, there's a picture that they'll show this bodge part and, you know, the value. I'm hoping. Or I could look in the Washington. Maybe that one hasn't been destroyed. If it's the same bodge part. Let's see if the Washington has that same bodge part. Of course the Washington does not have that same bodge part. Of course not. That would be too easy. That would be too simple. Nope. Nope, 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 nope. Sometimes the manuals are really good about showing those parts and what they are. So I'll have to just look around, see if I could find something. And okay, it's... Oh, I missed that part of glue. I didn't lift this component up. I didn't lift this cap up, so there's still more glue here. Oh well. Gotta get it off. Thought I got them all, but nope. Lots of bodge parts on this radio, so... But yeah. So, like I said, if you're watching, and you've sent your radio to somebody to have the caps replaced and the glue removed, and you wonder about, why is the labor so expensive? Because the guy who's doing it's probably doing this right here. Huffing fumes and scraping glue out. And it is time consuming. So. I'm measuring 20K there, but it's in circuit, so. See if I can turn that off, turn that back on, because that, I thought I reset, didn't work. So I have to go read the manual again to see if I can't figure out how to get in there and turn that bloody thing so that it stops turning the iron off. Because then there's no way to get it back on. You have to turn it off, turn it back on to get the damn irons to work again. At least it doesn't take much to get it back up to temperature, so. Let's see if I can get one lead of this thing lifted. But this solder, it looks a little bedraggled, so. Yeah, I'm having a hard time getting this old solder to wet here because of the corrosion. To get it up. I got one end of it up, so there we go. So now I got to try to get all this old solder up. Yeah, I got to figure out how to get that stupid timer off. This resistor is, on an ohm meter, 32K. 32.3K. So, who knows what it is? I can't read the bands, so got no idea what the value is supposed to be. Let's get that old solder out. There we go. Don't think any bits got squeezed through the board, so. Yeah, this one's measuring what did I say it was? Three meg? No, it wasn't measuring that before. This solder on the other side is just 32K. It could be just off because, well, you know, the thing was corroded. It was filled with glue. So the resistor's probably changed value. Have to figure out what it is. Let's get the other side free and get that solder sucked out. That lead is just barely poking through the board. I don't know what it's for. I think it's for this diode. Push that lead back through. Oh, it was a wire. Yeah, it was a wire. Okay. Come on. So the other side of this resistor goes to a wire that was barely poking through the board. Now I've bent over, so it won't fall back through. See where that wire goes. It might give us a clue. That is that white wire right there. It's probably part of the... Well, this radio doesn't have an SWR. It doesn't have an SWR bridge in it. So... goes down to... Is that C... What's C what? 108? I think. There's two capacitors there. I don't know which one of them is C108, if it's C108 or TR30. It goes down to a capacitor that has no silkscreen value. That's nice. So I don't have a component designator for it because there's no silkscreen component designator. It just goes to a wire that goes to a capacitor. So, yeah. Yeah, I don't think that component's going to get identified. Unless I get another radio that I can see a part in it. It will just have to stay put for the time being. So, you know, since we can't read the bands. I can't read the bands because it's just been corroded, so. And a little bit more glue spots. Overall, it's come pretty good and clean. So this should be good. So yeah, a couple of more spots need to be hit with acetone again, and sort of the glue removed. But of course, there's all the topside glue too, which is you know, at the components and all that kind of stuff. So you know, there's tons of glue down in here, and so when these caps come off, so when I start pulling these caps out, I'm gonna have to get that glue gone. You know, like this big one down here, this big filter, it's underneath all these bodge parts. So that one's going to be interesting to remove because I'm not sure I can get to it with the bodge parts. I'm not entirely sure I can get that out. I think I can get one lead right here. Let's see if that was... Yeah, that was it. If I can maneuver these bodges by... Yeah, actually, I think I can get it now. There we go. Alright, so let's take a look under this cap. This is 1010. There's the glue on the VCO, but did it get down to the pins is the question, because this stuff gets down to the pins. This usually, I mean, we know this radio's working. Ooh, it did not get down to the pins, which is why it's obviously survived. But yeah, it just, They just did it on the top of the VCO. Yeah, they didn't. It didn't go all the way down to the board, which is good. It pretty much just stayed on the VCO, dribbled down to the tantalum that's next to it, and didn't really go any further than that. So the top of the tantalum has glue, but it really didn't get... very, very, very little of it got down to the board. Yeah, I didn't think that acetone was going to melt anything in this. It's just nothing to melt on the board. It didn't melt the plastic tube. It's just filled with that damn glue. It's still filled with that glue. The glue ate up the resistor, not the acetone. So, yeah, to get that out, I'm probably going to have to get the chip out to get the rest of it out. I just got to get the chip out. Maybe not. Actually, I don't see much more down in there. I think I've got it all, actually. Yeah. Yeah. Because it didn't make it down to the board. So, yeah. Yeah, it's good. It didn't get down to the board. They just did it on the top of the cap along the side. And just a little bit around the bottom of the cap. That's about it. Let's see. Alright, so... since I got it out, I'll just put a cap in it. How about a nice 1000 at 16? That ought to work just fine. It's thinner. It's a thinner capacitor. They definitely have gotten smaller. Yeah, this one appears to be known for lots of glue too, because this sucker has... I think this one had more than a 148 has. It's a good grief. And this isn't the same board as a 148. It's actually a predecessor, I think. I think this is a predecessor. It's a single conversion type. The 148, I think, is a slightly better design than this. I think this was probably the first design, and then the 148 was probably the improvement. So, yeah. Well, that cap's in there, so that takes care of that one. Still got it all here on the metal on the side of the radio, this glue. It's a great day. This stuff is all over the place. Jeez, man. So yes, that cap is in at least. Of course, this VCO has 3 tantalums, and they can't be replaced but with identical types. They did these both at the same time. Okay. Because I'm fairly certain that this is definitely the single conversion type. So I think I just killed the other crystal. I think I just killed the other crystal. Yeah. Yeah, I killed the other crystal. Both leads just broke on the other crystal. Yeah, the other crystal was barely holding on for dear life, and I just killed the other crystal. That's not entirely surprising. Yeah, I'm not surprised by that. So what I've got now are just leads because they were all corroded. So both of the crystals, I mean, it was doomed to failure, you know? It was just doomed to failure. Even though the upper sideband and the AM were working, it was not going to work for long because as soon as I got in there like I just did to try to clean that glue out, it just finished the leads right off. So, yep. Rest in peace there, two crystals. The two 7.8 megahertz crystals, or 7.8 and 7.79 or whatever they are. Both of them, both of them are now in crystal heaven because they are kaput. So I need to get two crystals for this. Is the 140 the same as this? I thought it was. So I need to find a donor chassis with two crystals in it, which I don't have one. So I have to figure out if I want one of the Washingtons to be a donor. Probably because this radio is in good shape, so I think I'd probably rather have this one working. So the Washington becomes a working Washington. Both of them work, so I guess it just becomes a it becomes a donor. Too bad. So, anyways, that's all there really is, unless I get some news. Yeah, 7.8025. That's the two of them. They're dead. They corroded away. They got glued. That's one of them. Now here's the other one. This one, both the leads just snapped both of them off. They were all corroded. And this one actually, one lead survived because it didn't get glue on the one lead. Yeah, this one it didn't get any glue on the one lead. It got it on the other one, and this one got it on both leads. So, yep. Curtains, man, curtains for these two guys. So, 7.8025 and 7.7975. Bye-bye. See if I can find some on eBay or something. Probably not. Unless somebody's parting out a radio. So, yeah. I'll see if I can try to get some sorted. No big deal. To be expected. Usually it's like VCO chips and stuff like that, but you know, unless they're in the 140, they should be in the 148 as well. I thought. Big chunk of glue on the side. I'm trying to get it off. I got a 148 that is the NFG radio. So it uses the same crystal. I thought they did. Is this a 148? Yes, it is. No, that's right. They just used 7.8. That's right. The double conversion did it differently. It used one crystal. They offset it. They offset it a different way. They offset the other crystal. The 10 megahertz, I believe, on this one. 11.3258. Yeah. They offset on the other ones. They offset this, and on this one they offset. They offset that differently. It's just done differently. Same difference. So, yeah. Two crystals to make this work. VCO is fine. I gotta get this diode and these things all out. And what else do we have for glue? Usually there's glue down there, and I don't see any. They didn't glue that. They didn't glue that little coil down there. That's kind of curious. No, they didn't glue it. Huh, they didn't glue the coil. They usually do. 7.8025s on eBay. Alright, let's see. Emails. I have to read all my emails. I just got a pile of them. 7.8025. Ooh, they're the big fat leaded ones too. $1.50. Why would they have these? It's kind of an oddball frequency to have a crystal for, you know? And this guy has weird crystal values too. That's kind of interesting. 7.7925. No results. It is 7.7975. 75. Nope. I am going to wait until I know in the morning whether or not that other thing is actually going to show up, because I don't want to put my foot in my mouth. I would like for it to show up, but I don't want to say, yeah, it's going to happen, and then it doesn't. You know what I mean? Right now, I'm not entirely sure that it is going to happen. And that's because I'm looking at... I'm not a believer, let me put it this way, that it'll show up tomorrow. I'm not a believer. It's pretty late at night and no movement on it, so I don't think it will. But it's possible that, oh, they put more glue on the other side. I didn't even notice that until just now. Oh, Jesus Pete, man. It's crazy with all the glue. That cap has to come out to be replaced anyway. It's just, what in the world? I may actually have to get that VCO chip out. Yeah, that went all the way down to the board on that side. Yeah, don't send me your one crystal. Oh, it got down onto a resistor down there. Oh, no. Yeah, I got to get the VCO chip out. VCO block's got to come out. Oh, that's bad. Yeah, it got down to the other side. They glued it to the VCO tank coil. Jeez, man. It's really curious. Oh yeah, and then we have this inductor and these wires over here that they really glued this down over here as well. And this inductor looks like... actually, that's not an inductor. That's a common mode choke. That's a ferrite bead on a wire. It's a common mode choke. And wow. Yeah, I gotta probably get a whole bunch of components out here. I'm telling you, when those guys tell you that it's going to cost you so much money to get all this glue out, they're not kidding you. They really aren't. I mean, this is a pain in the ass. And I mean, I've done it. But this one's actually pretty bad in a lot of spots. This one's pretty bad. So. Oh, yeah. You could, but it wouldn't get here tomorrow. People are going to start asking, what is it? Wait till tomorrow. We're going to have fun with it. Let's put it that way. if it shows up. I don't want people to like be all geared up and fired up for a live stream, and then it doesn't happen because I don't have it. You know what I mean? I'm not trying to, have people like totally rearrange their day because I'm, do it like tomorrow evening, and it's like, okay, I really want to see what this thing is, and then it doesn't happen because it doesn't show up. I just don't want to do that to people. So what I was going to do is I was going to announce it in the morning if it really is going to happen. So since there's a little bit of a cat out of a bag, just look out for tomorrow morning. If you see it, great. If you don't see it, then don't count on it. Then then think about maybe a Monday night or something like that, and just basically push it 24 hours and play it by ear to see if it eventually shows up. I think it will. I think everybody will be pleased with that one. I think that one's going to be also a pretty long one because I plan on really getting into some stuff on that. Jeez, this glue all over the place in here. It's just dribbles. It's like they glued over here in the crystals and then they went like this. Because I can see little streaks of it. And then they went over like this when they were doing it. Boop, boop, boop. And they probably do a ring or something like that, and just meow. Don't worry about it. It'll be cool if it happens. It will be cool. It'll still be cool if it doesn't happen and it happens another time. I think it'll still be cool. I think it'll still be cool. This is a piece of tape in here. Oh, I know what that piece of tape is from. That was from the S meter, I think. It fell off and it was just stuck back there. Yeah, that's the tape from the S meter. Huh, okay. I was wondering why it wasn't covered earlier. When I was talking about how I did the S meter, it looked like just it didn't have any covering on it. That was it right there. That was the tape from the S meter. It just got down in there. So, But yeah, I think this is a good candidate for finishing up a restoration. And then I want to put a board in it. I actually have a reject board, like let's put it this way, /accident board. It's right here. And it's a /accident board because the black area over here, I just marked it all up because, well, it's a working board. I put the USB connector on and I didn't solder the ground bits, so I plugged the cable in and wham! Ripped the tracks off the board. So yes, this can no longer be field upgraded, therefore it is a dud board. So it goes in a test radio more permanently, probably mine. I have to solder the header on here. This way I can flash it, because now I can't flash it at all because I don't even have a plug for JTAG to plug it in. So yes, first one, and I even put side connectors on it, and yeah. Yeah, better that I found it than somebody else, let me tell you, because that's one of the things. It was like, okay, let me test these again. Boink! I didn't solder it. Yeah, and then I went and checked every single other board, and they were fine. That one, I didn't solder the connector. I'm glad it happened to me and not somebody else. I'm fine if it, because you know what? As crazy as this sounds, okay, this isn't a mistake. You know why? because it stayed in these four walls. If this board had gone to, say, Mike, or to, say, someone else, like Windy City there, it would have been a mistake. And yeah, but since it stayed in the four walls, it's not a mistake yet. So I'm glad that the mistake didn't happen. So no, there was no mistake. I know that sounds like a bad way of looking off. Thank you. I know that sounds like a bad way of looking at it, but no mistake was made because it didn't get put in the hands of someone. So no mistake was made, you know? But yeah, I went and checked every other one. I was like, oh no, please don't tell me that that this was something that I did, and it was the only one. I went and looked at every one of them, looked at them closely. It's like, oh, no, they're good. Yeah. So anyways, need parts. We'll obtain some parts, and then but in the meantime, I can, tomorrow I can recap it and I can clean up all the glue and thank the Lord. And I'm not having a religious experience, but yeah, it's just, no, it didn't end up. I've tried to be very clear about some things with regards to these boards. I do not want mistakes to end up in the hands of the end user. I just don't want it. So I'm glad that happened to me. It's fine if it happens to me. It's not fine if it happens to you. Then it makes me upset. So, yeah, happens to me, I can laugh about it. Happens to you, then you're mad at me, and I don't want anybody mad at me. I know I can't please everybody, but I just don't need to cause anybody that kind of grief, myself or anybody else included. So, that's why I went and reevaluated every single one of them again. I pulled them all out. It's like, okay, where there's one, there's usually more. So, pulled them all out. Okay. These ones? These have a 2.5 kilohertz filter. Do you mean this one? With this guy here? Or am I missing something? So, yeah. I want this. I think I want this one to be my car radio. So, I'm probably going to go get those crystals out of the Washington and swap them into this because I'm anxious to know if the radio that works. You did? I usually look at my PMs on DSL reports. Let's see, I got one of my threads that I'm less subscribed to. Let's see. Okay. Well, let me look at my messages on DSL reports. Doesn't work that good on the phone. Let me close it and open it again. Usually there's a thing over there. You got a little menu. My instant messages. Which one are you? Did you send it on the 31st? Yeah, I have a feeling it'll be fine. Yeah, I'm just wondering if that's you who sent me the Jesus Pete. Well, hell with it. Since I need to find out if it's gonna be fine, let me just suck them out of the Washington really quick. I just caught this iron when it was cooling off too. That's me. You got it. Yes, I'm a frequent antagonizer on DSL reports. Actually, I don't antagonize anyone. The only one who doesn't like, who probably would read DSL reports and doesn't like me would be Ajit Pai, the new FCC commissioner, because I think he's a narcissist fuckwad that, you know, we don't need to have any kind of responsibility in government because he's a corrupt, thieving liar. But now that I've said all I feel about Ajit Pai, our new FCC chairman, yes, I don't like him. If I haven't made that very clear, because he's a thieving liar. Acetone worked fine to get it off the glue. Yeah, I'm just trying to scrape some of the little bit of glue that was on the crystal out of the Washington. And now I'm going to get the other one out that's next to it. But yes, Ajit Pai will not do anything. Well, net neutrality, he's totally going to make it go away. And I laugh at all of these people who are like, oh, but they're using net neutrality to attack conservatives. No, they're using net neutrality to protect you, you idiots. Oh, they're going to use net neutrality to silence conservative speech. No, net neutrality is there actually to preserve your speech. He's an idiot. And people who believe that nonsense are idiots. It's there to protect you all. You know? I thought Wheeler was going to be a complete disaster. I think he turned out to be the best FCC commissioner in a long time. I mean, Michael Powell was a disaster. Michael Powell was a disaster. Wow. You know? I mean, Michael Powell was oh boy. And then we got that other bloke after him. I forget his name. Who was also a disaster. And then we got Wheeler. And he actually gave a crap about people. I was just like, am I in like a dream or something? He actually cares about people and not big government and, pro megacorp. And I was like, am I in the usual, am I in America still, or did I end up across the border in Canada? But no, Ajit Pai is a disaster waiting to happen. He is a disaster. You want to talk about broadband prices going up? Oh, yes, buddy. Because he's going to give those corporate overlords exactly what they want. Your privacy rights? Gone. Gone. Completely gone. Cable set-top box reform? Not going to happen now. Was taken off the agenda. That means your cable box rates are going to continue to go up. Because that was one of the things that they were trying to curb, was cable rate boxes, charging for cable boxes. Like, you can't buy your own cable box, you have to rent it. You don't have a choice. We need to get rid of that. People should be able to buy it, and then they don't have to rent it. Alright, let's see if we got AM transmit. Hooray! Yep. We have AM transmit. And we have lower sideband and we have upper sideband. Whoa, yes. Oh, I think it's been screwdrivered a little bit. Yeah, it's been screwdrivered a little bit. It's all good. Yeah, I mean, that's just the thing. They're just going to keep increasing rates. And the only reason they're going to do it is because they've got Ajit Pai who will now protect them. Because it's like, you know, everything for big business, man. Everything for big business. This is a TRC 450. But yep. It's fully functional again. Hello, hello, hello. Hello. Yep. I think it's been screwdrivered. Because this, you know. Hello. Hello, hello. Yeah, it's been screwdrivered. Let's see if we can find the AM power has probably been fully rotated. Yep. Yep. Definitely fully rotated. Let's turn that back down a little bit, shall we? There we go. Some sensible value. There we go. Much better. Much better. Let's see. Do it a little bit more. There we go. That's good. Hello. That's better. Now 4 watts. It was about 8. You know. It's just no. I don't like them that high. You know. I don't like it that high. Just whoop. Turn it all the way up. No. Let's not do that. You know. Let's not do that. So, what is a transistor or a resistor or whatever it is that they cut in these radios? I'm wondering if it's been cut. I don't think it has, because it doesn't seem like it has that kind of screaming modulation. So I don't think anything's been cut, unless the microphone or we got another problem. I'm not finding anything down in here cut. Find some more glue though. There's some glue down in here that needs to come out. But I'm not seeing anything cut. At least not off the top of my head. No, nothing's cut. Usually they cut something in here if they're going to do it. No, no cuts. No cut parts. No, I'm not feeling the acetone. If you mean because I'm talking about Ajit Pai, no. I'm feeling the fact that I do not like that guy. Because he is going to screw me, you, and everybody else. You know? I mean, all he's been doing for the last, 5 years has been talking about how much he absolutely hates the fact that, you know, free enterprise, as he calls it, you know, can't charge, he shouldn't be allowed to charge money for cable boxes. I'm all for companies charging money for cable boxes. I'm all for it. But I'm all for allowing people to have the choice to get out of it too, which is to buy their cable box. If you can't buy your cable box, there's no free market at play. That's the problem. It's all monopoly. And he's pro-monopoly. You know, so Wheeler was not. Wheeler was trying to level the playing field. That's why we have bandwidth caps. Just think about it. When bandwidth cap, I just want to put this in perspective. Okay, so I'm doing this live stream with this radio here. Okay, we're watching this live stream. Well, you're watching the live stream, and I'm talking about the radio, working on the radio, and so on and so forth. When they cap my internet access, this live stream, gone. No more. No more live stream. I couldn't possibly afford it. It would cost me hundreds of dollars. IPTV isn't the future anymore because of bandwidth caps. Because if you had no bandwidth caps, D42. Where is D42? It's down in that section, right? Well, that's 70. 29, 31. See if I can find D12. I don't know if that's in this section. Well, there's 39. There's 1. Nope, 70.
Well, if there's 39, it's got to be in here somewhere. So, unless it's just not in here because there's 40. Okay, so there's 40, 41. Oh, I got to be homing in on it. I got to be homing in on it. I see a missing spot. Whoa, I see a jumpered spot. That's curious. It's just a wire loop through R94. There's a wire loop through that. I mean, R94 is a looped wire. That's curious. I don't see a D42. Not yet. Still looking. D44. Got to be around there somewhere. I'm in the right area. Clearly. Oh well. 50. Nah, I don't know.
There is no R94.
Well, there isn't one in here either.
It's a piece of wire that's jumpered across it. It's literally a loop of wire that's in the spot.
And I don't think anybody's been soldering in here. So, yeah, I don't know where that D42 is.
I can't spot it.
Right, because it has an 8734 in it. You can't do anything with the 8734. So there's 31, 30.
If when I mod this, I'm not going to do anything even with the 8734 or the 8719. I'm just going to pull the whole chip out. So
I'm just trying to see if it's been. It doesn't look like it's been modded for more modulation, because this radio doesn't seem to have that spectacular of modulation, which is why I turned the AM power. One of the reasons I turned the AM power down is because it actually didn't seem like it had very much. But the reason it probably might not have much is because there's a lot of caps in here that just I haven't recapped this. So, you know, that's, you know, probably going to be reason number one. Poor caps. I mean, this thing needs tons and tons and tons and tons of capacitors. I mean, let's see, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 17, 19, 21, 22, 23, 24, 25, 28, 6, 7, 8, 9, 30, 31, 32, 33, 34. If I've counted them all.
damn near 40 caps. To the right near the modulation transformer.
Oh, well, that'd be why I didn't find it in that area. Huh. I mean, that would make sense that it would be there. I wonder if it's this diode that I busted. I can't tell if it's the one where the lead broke off of it. Yeah, I can't tell. Unless it's another one somewhere else. 14, 13, 16, 13. It might be that one with a busted lead. But if that's the one with a busted lead, and it's busted and it still hasn't perked it up, then it's just bad. It's got to be bad caps galore. It's working. This radio needs recapping bad. The silk screen's corroded off. I can't tell if that is the diode. Yeah, I can't tell. Right rear. You said right rear. Not right near, right rear. Right rear. If it's depending on which right rear we're talking. Oh, I see it. D42. There's a resistor there. There's a resistor in the place of the diode. With a painted lead, too. But it's not painted the same color as the other painted. Yes, it is. Yes, it is. It's the same color as all the other painted leads. It's a resistor, not a diode. Just curious. That's curious. Why they put it? Somebody put a resistor in it. No, that's not what I just saw. Wait a minute. Okay, so there's VR6, C120. Oh. What the hell? I don't think my board matches up. The one you're pointing at is D62 on my radio. Yeah, the one you're pointing at is D62 on my radio. D42 has a resistor on it. Mine's D62. D42 is next to it. Oh, yes it is. It is intact. There it is. Oh, you're pointing at D62 in your picture. You're actually pointing at D62. D42 is the one next to it. I see it here. Yeah. Okay, that makes sense. Yeah, as soon as you said it was a 1N60, I'm like, no, so it's not that little bugger. It's got to be that other one right there. Yeah. Right, you were pointing at 62. Or were you? Yeah, that one you were pointing at is 62. The one that's the one that's to the right of where you're pointing at least from the perspective I'm looking at. That one was 42. It's a glass diode. I'm not going to snip it. But yeah. Recap the radio. Yeah, needs some recapping. Voltage regulator is getting warm, probably because bad caps. Hang on a second, guys. All right. Yeah, so recap is what it needs. Needs a recap. I'll leave those crystals in there for now and get some put back in the Washington. That Washington's actually my test bed radio, so I probably should, you know, fix it back up because that's one that I test the boards in. Even though this is the same board, I could totally use this to test boards in because, well, it's the same radio. I just get it working in this. You know, pull out this PLL, recap the radio, pull the PLL, put a socket in it because that's what I use for testing. Put a socket in because it has a socket in it, doesn't it? Or did I solder a board into it? Oh, I don't have a board. Yeah, it's got a socket. I don't have enough boards to solder in.
Yeah, I don't have enough boards. I only have one. That's it. And not this one. Like, I have one full set. Yeah, when I say I have one whole set, I literally have one whole set. Although I am getting more. People ask me about this on occasion. You know, how many do I have, and what did I do with them? Where did they go? Yeah, I have a whole box full of them. I actually just threw a whole bunch of bloody microphones on top of them. What the hell did I do that for? All right, so boards. Yes, all these beauties. Yes, I have. That was something that we were working on. And yeah, you know, two heads is better than one. And not really. I mean, they're not difficult to assemble. They won't stand up. But yeah. That was something we were working on. The problem with the 145 170 is that in a radio like this, you don't get the range, because that only will give you a maximum VCO voltage of 5 volts. Whereas you can drive this all the way up to 8 volts. So you lose, you can get good range out of it, but you can't get all of it at once like you can with a 145, 106 or the like. So there are some limitations to it, but it works. You know, there are limitations, and that's basically the only thing. However, this is going to be the next one I try, is this beastie right here. I haven't tried it in a 148. One of these. Going to put one of these in a 148. This is arguably better than the 145 170. What he did, which is actually quite novel, is he's just driving the input of it directly from the VCO. That chip is probably working off of a harmonic because it can't take that full 30-some megahertz. But this can. So this is probably a better chip to try. This is what's used in the whatchamacallit, the SSB980 that I had earlier. That's this PLL. This is easier to obtain than the 145 170 because these are all over the place. And these are, Rome has not labeled these. Once they label them not recommended for new design, that's pretty much it. They haven't done that yet. In fact, these are in new designs. They're in the SSB980 and friends. These are still a production PLL. It's one of the few, which is why this is a good candidate for what he's trying to do. I just haven't had a chance to hit him up with that and say, hey, this really ought to be the next one to try. Because this one's a little simpler to control than the 145 170. Actually, this one's easier, a lot easier to talk to. But the 145 170 has something this one doesn't have. The half reference output, or the programmable output on that divided, your reference. It doesn't have that. So this wouldn't work in like a 29 or a 25, which is I think what he's targeting. This wouldn't work in there. So it may be a moot point because I know what he's trying. I get what he's doing, and that wouldn't work. Completely not work. So Anyways, yes, plenty of boards. If you want an 858, right here. If you want an 8719 with one of these, with just the straight chip, probably the same thing. The issue is the control voltage. The maximum, the PLL runs at 5 volts. The 145, 170 runs at 5 volts. That means its phase detector output can only go up to 5 volts. Whereas the 8719 radios, they have a VCO voltage that runs from about 1 volt to 8 volts. So the effective range of the 148 voltage control range is about 4 volts. So you're losing 3 more volts because it just can't go any farther than that. So you can get the bottom, you can get the middle, you can get the top. But with the 145, 106, you could say you can get the bottom and the middle, or the middle and the top. You know what I mean? You can just get more range out of it. That's its limitation, and that's just, you know, how that one is. However, mobile mounts. Are you talking about these for the 148? Those are sent off. Yeah, those are sent off. Not yet. It's the 4th of February. Okay. I say 2 weeks. I should probably have them. I didn't do them rush, because, you know, rush costs more money. So, you know, I could have gotten them faster. I probably could have gotten them for not next week, the week after. I'll probably get them not next week, the week after anyway. But yeah, I sent them in. I sent, and with the 145, 170, he will cover both. Yes. He will cover both with that. That's not a problem. Yeah. As crazy as it sounds of trying to cover in radio like this, for a lack of a better way of putting it, the New Zealand band, the USA band, and the 10-meter band can be covered with a 145, 106 for the most part. They can pretty much be covered. With the 145, 170, I think you could get the New Zealand band, the American band, and you can get, or the American band, the FCC and 10 meters, but not both. I can get pretty much all close to all three with the 145, 106, but the 145 sitting that you can't get all of them. You can get, but you can get 2 of the 3, which is, I think, for what he's trying to do, I think it's fine. I think that he is achieving exactly what he set out to do. You know, I think what he's doing is you know, perfectly fine. You know, I mean, kudos to him for sort of persevering with it. The reason that I didn't really persevere with chasing after them is because I knew I couldn't get all of it. So I just gave up because I was like, well, it's not really feasible. Anyway, I'm going to walk over to another computer. I'm just going to tell you guys what I got from Elecro. I don't remember because I have 2 orders in right now. Come on, computer, wake up. Wake up, wake up, wake up. Okay. I've got the following stuff sent in. Let me log into this site and just look, because I've got a folder on my desktop with, you know, that's sent center Gerbers, and I want to say some of these I already have. And I think I just reordered more. So, come on, log in. Let's see what the 2 orders are for. That's interesting. The one that I submitted on 2.4, are they really building the ones I submitted on 2.4 before the ones on 120? Okay. All right. 120. I didn't make the cutoff. I got let's see. More 145 106s and more displays of the existing type. The ones that you have to adapt. And that's because I thought I was going to run. I did run out of the 145 106s, and I actually don't have very many of the other modifiable displays left. I think I've got like 10 of those left, so I need more of those. Now the stuff that I submitted on 2.4 is 4 boards, O2As, prototypes for O2As, just to adapt the O2A straight off. 2824s that are prototypes. The 148 displays and test boards. Now what I mean by test boards is, incidentally, here's another one of these boards that was sitting over here on the desk. So, yeah. Yeah. All right. So yeah. Anyway, here was one of these boards. So yeah, it just doesn't have the connectors mounted, and that's because it is. The way this works right now on an 8719. So take a radio like this. I want this radio to be on 10 meters, which is, I talk on 10 meters. That's one of the reasons why this thing exists, because I use it to talk on 10 meters. In fact, when I tune the radio, the radio operates for shit. What was I saying? It doesn't work that great on CB. So it's kind of pointless. You remove the channel selector, you remove the PLL, you solder a board in, you remove a 1 resistor. You put this board in, you mount this thing in, you mount the display in. You guys that have done them, you know what I mean. So it's really easy to do. Grant Fullen, hello to Grant Fullen. It's really easy to do. So you put it in, you know, you do a little tweak to the VCO, you're usually golden. Now you want to go take it out. Well, and the other thing is you look at the radio, and a radio like this is stock. None of the switches are modded, none of the knobs. You don't have toggle switches in the place of these sliding switches, none of that, you know, stuff. You know, it looks like an original radio. You know, it looks original. You open it up, it's clearly, you know, you're going to see something like this sticking off the side of the radio, but, you know, for the most part, it will look like a straight radio. You turn it on, you look at the channel display, well, there's 3 digits, yeah, you know, that's going to be a giveaway, but, you know, it beats having like a TS50 in your car. Yes, keep it simple. So, you know, like let's say you didn't want all the channels. You know, you didn't want to have the 10 meter range. You didn't want to have crazy channels. You just want what the original PLL can do. Well, I've got these right here. I've got made ones instead of showing those on the board. I've got ones that like are done. You know, I've got my test versions, obviously, of those boards. So let's get my test versions. All right, so I have these boards. This is obviously my 145, one of my 145, 106 test boards. Okay, well actually there's two of them. One's in a socket, one's not. You know, this would be one like that probably was soldered into a radio and I unsoldered it. That one's got the long pins, so it just goes in a socket. You know, it's a test. They're test boards. But anyway, so PLL soldered on this one. This one it's in a socket because it's a test board. But here's your 8719. Okay, so on here is an 8719 PLL. I can just solder this right into the radio in place of this PLL and be golden. And then just plug my ribbon cable into this. I can get the 127 channels that the native PLL can do. No modification at all to anything. No, you don't have to take out one resistor. Nothing. It will just work. This is the 858 one, arguably here without 858 chip. I just have a socket. Again, my test board, and the 858 would pretty much go into this. Okay, just like with the 8719, the 858 you would remove from the radio. You'd put it in this. You'd put this, solder this into the radio, and plug in a ribbon cable. You don't have to cut any traces. Yes, so keep it simple. Absolutely. No traces have to be cut. None of that has to be done. If you want to put the radio back later, okay, I got a new radio. You know, I want to put this in another radio. Pull a board out, you could, if it's a similar PLL, you could just take the PLL, put it in your old radio, pull a board out, put the parts back the way they were, the channel selector, bolt it all back in to stock radio again. It can be reversed very, very easily, because one of the things I do not want people having to do is cut traces and all that other stuff. So yes, that was kind of the concept behind this. Now here's the problem with like the 29. I don't think we're going to get away with that on those radios. Let me get these things out of here. The same 127 channels that it's capable of. It does not do any funny shenanigans with pin 10. The reason that I've kind of shied away from that is because I'm not entirely sure that adds a lot of complexity. I will make a version of it that will do the pin 10 business. Yeah. Here's the thing. You know, this radio aside, it's cooled off because it needs to be recapped. The thing's voltage regulator was burning up in this. It's just bad caps. Where's my Grant? Where's my Grant? Here it is. All right. This is usually the Grant that I use in the car. I brought it in because I was actually going to put this rev board in it. Right. So here's the thing. This radio is actually fairly stable. It's surprisingly stable. I haven't had really a drift problem. They're pretty good, but you know, think about it. It's a Grant, okay? You know, nitro knobs. You're gonna have to tell me how those, even with kit board, well, I don't know. It depends on what you want. But anyway, this, as far as like, this is my This is like my radio that I use. And you know, it's fine. It works good. The advantage to this is if they steal a Grant out of the car, they smash the window and they steal it, I'm not out a whole lot. But I had like a Kenweird in there. I'm out a lot of money. I did this so that I could get a cheap radio on 10 meters to put in the car, you know? That's kind of the thing. So, the Def Palm. I still kind of chuckle when you tell me about how you finally told me the secret of the Palm, about the Aussie slang. I still kind of chuckle about that. They call you a Palm. The Yanks call us limeys. No. I'm not taking it like that. I'm, you know, I think I understand what you're getting at with the whole, you know, doing some. I think that tweaking the hell out of things is kind of fun to me. So I don't have a problem with it at all. I think that's cool stuff. But what was I going to think about? What was I saying? What was I thinking? Thinking I need to get this out, but anyways, I was thinking about there, since we have the Def Palm. The Palm. Oh man. Your boards that you're talking about, the one with I take it the 145, 170. Have you thought about these? BU 2630F. No, the EMI tape is not ground. You mean here? No. Some radios need the EMI tape, some don't. 40 and 80 meters? Woo, I don't know about that. No, you don't want to ground the EMI tape. Not in this, at least. Yeah, I don't like external changes, Peter. Well, if you want, to play with that one next, that's you're going to give me too much to think about. Yeah, you know, the 170. I thought about it because I saw the video. You know, where you just injecting the VCO right back into the FN, but the FN doesn't operate at that frequency, and I'm wondering if you're locking onto a harmonic. That's the only thing that I'm rather anxious about, is the fact that you're actually locking onto a harmonic. And if you're locking onto a harmonic, then it's going to be unstable as hell. Because I don't think the 170 can take 35 megahertz to the face and work properly. This one can, which is kind of what I'm thinking about. This PLL can go up to 80 megahertz on FN. So you don't need the... It does? All right. Did I miss that? I mean, if it does, then there's no problem. I could have sworn it said. I'm looking for the bloody thing on my phone again. Oh, 145170. Yeah. Let's see. Maximum operating, you're right. Maximum operating frequency 185 megahertz at VN, 500 millivolts peak to peak, 4.5 minimum supply. 100 megahertz at no, that's at VN. Oh, well, maximum operating frequency would, yes, duh. At VN, 500 millivolts peak to peak, 4.5 minimum supply. So At 4.5 volts, it's 185 megahertz, and at 3 volts, it's 100 megahertz. So, yeah, it'll do it. You're right. Absolutely correct. Okay. I must have read, I thought I read somewhere in there about, a maximum 2 megahertz limit in the phase detector. That's where I got that from. Okay. Yes, I stand corrected. So the 145, 170 will do it. The only thing I'm thinking about is, take this away. The 145, 170 is the more and more unobtainium situation. This is an actively produced PLL. The BU2630Fs are used in even all current production, a lot of current production radios. It's used, and it also has 2 PLLs, which I thought could be useful for something, because it has 2 integrated PLLs with 2 separate registers to control them. I thought that could be neat. You guys, someone asked me about the SSB980. Who was here to ask me about it? Because I covered it earlier, and then I put it away. Is that person, whoever it was that asked me about this, is they still here? Because I will bring it back out and hook it back up and show again, what's going on with the 980. All right, so this is the BU2630 phase lock loop. It's serially controlled. Oh yeah. If you have 50 of them, then yeah, you're good for a while. Anyway, so this is the BU. Okay. Well, I'll connect this back up. All right. So there's my data cable. This is the BU2630 HMI. Oh, I think I know what you're saying. Anyway, BU2630F. You have a plan. Yeah, we all have plans, I'm sure. I'm waiting for the 2824 prototypes to show up. When the 2824 prototypes show up, that's going to probably be interesting, because that's going to be the 300 channel Cobra 29 human machine interface. Oh, okay. All right, so a brief overview of what's going on here. Okay, this is a ATmega. This display is not doing anything. It's just there because I was using this for something else, and so the display actually does nothing. It'll just show gibberish because, yeah, as you can see, it just shows gibberish. All right, so the only thing that are working here is there's a small, about 200 and some line program on this micro that takes data from this encoder. It does some computations, and there's a few values that we need to compute in order to compute the valid reference and encodes, if you will, for this radio. We need to know the reference frequency, which in this one is 10.2417. We need to know the VCO offset, which is in this radio 10.6975, I believe. Yes, 10.6975. And how many steps we want to do and all that wonderful stuff. So there's a little bit of math going on in this to do the computations in order to program the PLL. So I need its microphone, because it has a unique microphone. And what did I do with it? Uh-oh. I had it somewhere. I swear I had it. You guys saw me with it earlier, but I don't know what I've done with it now. I've moved stuff around, and now I don't know what I've done with the bloody Bearcat and microphone, and I only have one of those bloody microphones. Uh-oh. Uh-oh. This might be a, is it under there? There it is. Whoo! I only have one of these bloody 6-pin, 5-pin, 6-pin microphones. So we turn this on. All right, you can see that we got this rubbish display that we can't do anything with. The frequency counter on it's worthless because it doesn't actually, it's not an actual frequency counter. You see, that's not where the radio is. The radio is actually on somewhere in Never Never Land. 26395. And I'll do what I did earlier, which is to get this camera down. They do, and I don't know where the adapter is. So there's a radio, okay? That's the frequency that the radio is putting out. And I just spin this a few turns because it goes 10 kilohertz steps, obviously, and we end up 2774. So I can just turn this by one little tick and 26755. So yes, you know, this is all that's going on here. I'm just injecting my own data stream into this PLL. This PLL is disconnected from the micro because, like I mentioned earlier, there's countermeasures in the software in this micro. If this micro detects that I'm controlling the PLL or I'm sending data over the bus, it's monitoring the bus, it freaks out and resets the radio. So yes, well, I've actually severed the two, because if I override it, this micro detects that, and it resets the radio. It's got a countermeasure, so you can't just bodge some wires into it and change it, because the micro monitors the bus, because it is just a serial bus, and everything is, this is on that serial bus, this is on that serial bus, and this is on that serial bus. Oh, there's also on that serial bus, if you look down there, you see the two ICs. I'm trying to, there we go. These two guys down here, one of these is a DAC, I believe, and it is also on the bus. So, you know, the only difference between this and this and this is they have their own chip select lines. So the microcontroller obviously tells the chips which one's talking to, you know, because they all share the same bus. So when it's talking to this, it toggles a line. If it's talking to this, it toggles a line. If it's talking to this, it toggles a line. So, you know, depending on which peripheral it's talking to, because it's SPI, it's SPI. So, you know, depending on who it's talking to, it toggles a line. But it's listening to the bus. So when you see in a micro, when you see data on the bus that it didn't send, it resets the radio. It's clever. So they did a pretty clever job there. So if you send something on the bus, whoop, that's it. Lights out, it just resets the radio. So you have to cut the PLL loose. I did that on the bottom back here. You can probably see that area on the board. Trying to not like pull out the camera. Right here, it's not really focusing that great. I think I got the autofocus off. I cut them and then I put them back, and then I cut them and then I put them back, because there's no easy way to isolate it, so I just cut the traces. It is, and when the MCU detects that you have taken control of the bus, even for a moment, poof, it just resets, and because they're monitoring it. I looked at the timings and everything like that. It's bit banged. This particular, just to just put it like this MCU that's in here that we can't really focus on, it does not have a hardware SPI, so they're doing it all in software. So it's not like these AT Megas where I have a hardware SPI controller, and this is just doing hardware SPI. This is doing software SPI, so it's monitoring the bus, because normally you couldn't monitor the bus that way. So they did it software. Well, the chip doesn't have the hardware. This MCU down in here, it doesn't have the hardware for SPI anyway. It just doesn't have the built-in hardware SPI controller. So they're just monitoring it. So when it sends its command, it immediately probably just listens to the bus. And if there's something on the bus, because you got to think about it this way, this chip and this chip, they don't talk to each other, nor does this and this. Nobody talks to anybody else. So you got the clock and the data line that's just monitoring the clock and the data line. So nobody's talking to each other. So if it sees data on the bus that, corresponds to something else. Here's another thing I think about. If I send data on the bus, okay, and it doesn't have to be for the PLL or for this is IO expander or for this PLL here. It's just data. I just pulse the lines. It doesn't do anything. But it's when I send the specific data packet, the specific 24-bit packets, the two 24-bit packets to this PLL that would be destined for this PLL, they don't even have to be 24-bit packets that make any sense. It can be 24 ones. It will reset. I think it's just counting clocks. And if it sees 24 of them, because this PLL is very specific in its width, if it sees 24 bits, that's it. It resets the bus. So I think they deliberately put that countermeasure in their MCU code. I think it's a deliberate countermeasure. So, yeah. There's another countermeasure in here that will destroy the EEPROM contents that I tripped up while trying to play around with its serial interface, because there's a serial interface on the MCU. I start playing around with that, and I tripped another countermeasure that wipes the EEPROM, which thus renders a radio inoperative. It's a masked micro anyway, so it's not like you can extract the software application. But yeah, the CPU, give up. The CPU and the radio, give up on it. It's just not going to happen. But you can control the PLL independently. It's just not practical because, well, it just doesn't make any sense, because the display isn't going to reflect where you are. Like right now, it's somewhere else, and it doesn't reflect where you are. However, tell you what, this radio goes from 26 megahertz stock, okay? Exactly. Well, let me put it to you this way. Yes, it's booby-trapped. These are booby-trapped. Don't play around because they're booby-trapped. They do have a self-destruct. I don't know very many software developers that do not booby-trap their code. I booby-trap it because it's just course of business. If you do something even remotely flaky on this board, that like if you start probing its bus, it will wipe its contents. Don't do it. I suggest you don't do it. Don't get cute and probe its bus. If you probe its bus, it'll wipe itself. They didn't do that, but I did. It'll wipe. That's it. There's a logic bomb in there. So if you got in here and started probing this bus by pulling on it, yes, they'll brick it. That's what they do effectively by wiping the EEPROM, because then the EEPROM contents are corrupted. It'll brick it. It'll brick. The only way I was able to unbrick this radio was to get another radio and copy the EEPROM contents. The EEPROM contents are non-specific to the radio. It just needed a value in a specific location in the EEPROM that it checked as a software, like it's okay to boot kind of a thing. So when it boots up, it checks EEPROM, reads EEPROM contents, which is usually just settings like what color you have at the display, the last channel, all that stuff. You know, typical stuff you'd store in EEPROM, and it reads those contents, but it seems to be looking for a specific bit in a specific location. And that's from when I was sniffing the bus between the micro and the EEPROM. But the only way I was able to sniff this bus without bricking it between the EEPROM and the micro was to optically isolate it. So I've got a board around here somewhere. It's about the size of this board here, and it has optical isolators on it that I can put my logic probe on one side, and I can put these optical isolators, I can attach them to the bus. Because the problem with logic analyzers, when you attach them to the data bus, they pull the bus up. You know, exactly. I mean, could I build a radio? I'm not an RF guy. This data stuff, this, you know, logic and software applications in the electronics, this is me. This is my realm. So I know how to get around these kinds of shenanigans that they pull. Now, I'm not entirely sure that that's really a countermeasure or not. It's just something that I tripped. I could have very easily tripped a software bug, which is something else to consider. Did I just trip a software bug? I could have, and it could just be it wiped it, EEPROM, it just sent bad data to the EEPROM and effectively killed it. Because when I looked at the EEPROM contents, it's just like a 24C16 or something like that EEPROM. Fairly standard, bog standard I2C EEPROM. You could teach who enough? Me? Probably. I could always do some new tricks if you got some. But it's just a standard bog standard off the shelf. What's going to be the focus? I'll watch. If it's cool stuff, I'll watch it. Yeah. This is just, you know, pointless to screw around with this micro. It's masked anyway. You know, it's not like you can dump the software application because it's masked. But you know, it's pretty much it's created with the firmware on the chip already. It's not like you can upload new firmware to it. They didn't make these things really field upgradable. What would be the focus of your channel? I mean, personally, I don't think there's enough work being done in this space. I think right now, the only people who are doing this kind of shenanigans, trying to get to radios, you know, at this low of a level, is me and Def Bomb there. I think we're the only ones. I haven't seen anybody else doing it. A really good video, when I do the videos, I use one of these. Okay? So, I use one of these. Bloody hell, can't see the model number. HC-V770. I use one of these. You know, on a cell phone. This is a fairly good camera. You know, you meant cheap. So, AB5NI. I don't know what else to call you other than AB. What would be the focus of your channel? What would you do? You know, let's you know, not holding. Oh yeah. What would you do? I definitely will watch if you do interesting stuff. There's like a select few channels out there that I like watch. I mean, I really don't have like a whole big long list of guys that I watch. really explain RF. Like at the okay, I would be game for it. I'm not an RF guy. I think I slept halfway through my my classes, you know, when at university on RF. Because I didn't really care about it. I think I slept through half of them, and I think at best got a C in some of those classes. I just didn't care about it. What I wanted to do at the time was microcomputer stuff, code, stuff with this, you know. So that was sort of my focus. And so I didn't think to pay attention to those classes like where PLLs, they do get into RF and yes, they do get into RF. You know, it's at a fairly low level, I guess. Well, it takes a long time to learn it, and here's my thing. I've slowly figured myself out with like the face lock loops, which is how I've been able to figure these things out. Yeah, it's covered, but it's not. There's frequency synthesis and these other kinds of things that are covered, but I really think that it's not covered in a way that you're just going to come out of, yes. Frequency synthesis was covered at university. Those were the classes that I've taken and then we got like C's in because I really didn't pay attention to frequency synthesis, which is this stuff here is frequency synthesis. I've been slowly getting it back by playing with it. It's coming back to me, but that was a really long time ago, and my focus over the last 8-10 years has been microcontrollers and FPGAs, basically VHDL or HDL languages. So well, I would be a subscriber if you do it. I will be a subscriber. I'll line up if you actually are going to do some proper RF stuff, because it's not easy for somebody like me that didn't pay a whole lot of attention in his frequency synthesis classes to get some of this. I've had to go back to some old textbooks and actually look, and not to mention I didn't apply it. I look at this and say, okay, I didn't apply any of that stuff that okay, you get out of university, what do? Okay, yeah, we're going to write code for, microcomputers. FPGAs, yeah, Verilog or VHDL, I know both languages. There's actually a guy, do it, do it. Yeah, there you go. Well, I don't have a problem with collaborating with other people. I really don't. Me and Def Palm there sort of had a small collaboration, if you will, with something. Like the 145, 170. We played around with that. I think that between us, mostly him persevering with it, we worked it out. I don't think that that's I think that kind of thing worked out really well, and I don't have a problem with doing it. Yeah, there you go. But if you're gonna do like deep RF, other than what I already know about it, like I know enough about RF, that I probably, I get you have to cover it from beginning to end, but I know about like frequency synthesis and that sort of thing. I've gotten reacclimated to it, but some of the deeper, more voodoo-y kinds of things. For example, I tell you right now, I couldn't design an RF circuit worth a shit. I'll tell you that right now. I sat there in LT-Spice the other day and racked my brain trying to figure out RF. It was okay. I need to make an amplifier, and I know how to do it, and I know what I need to use, and I know the math, but it just like I struggled with it. I really did. Well, inductance and capacitance, yes. Yes, I struggled so with the that's exactly what I did. And I tried to increase the speed of it, basically. I changed the components, obviously, the ones that will go fast, that will, work faster. I ended up with a 2N quad 2 because a 3904, I simply couldn't get it to work in LT-Spice at a couple of megahertz. I would get waveforms that looked like someone sawed the top or the bottom off of it. Yeah, I'm not good with it, I'm telling you now. I can do audio, I can do digital stuff. RF, nah, it wasn't working for me. I was close. Bias is half the supply voltage? Okay. So if the supply voltage is 5, it would be 2.5. Okay. The math applies to an actual CB mod. Define a CB mod, because that's a little broad. 1 second. Where's my LT-Spice picture? LT-Spice is great. I love LT-Spice. I do everything in LT-Spice. LT-Spice. Gonna open up my little doohickey here. Let me just print this thing, and hopefully it prints it halfway decent that it can be seen. Yeah, that works. That's what I came up with. You can laugh and tell me. You can laugh and you can tell me how bad this is. All right. So, this is what I ended up with. You can tell me how bad this is later, but this worked. This worked. In LT-Spice. Let's see, I got it probably too dark. All right, there it is. Yeah, you could probably whack this into LT-Spice and see what I came up with. But yeah, this is bias right here for those who don't know. Yeah, this is bias right here. This worked. But it took me like longer than it should have to figure out the values that would work for RF. It's a 2N quad 2. The same circuit with a 3904, I was getting all kinds of just... I can probably draw it easier than explaining it. Which is indicative of bad biasing, actually, what I was getting. Right, and this will work up to about 3 megahertz. I was getting something like this. You know, it was like a little hump, you know, at the bottom. Yes, I was getting a little hump. This is a bad drawing, but I was getting a little hump at the bottom, like so. You know, on the, either at the top. Sometimes I was getting it like, you know, like dip in there like that. You know, it's just like biasing kind of an issue. Well, no, your 3904 basically turned it, yeah, on this, until I figured out the correct combination of R1 and C2 and R3 here. The emitter follower and this and the cap and the yeah, it needs to be amplified pretty big. I didn't get that kind of gain out of this. I was thinking I probably needed 2 transistors to try to get it up higher. But on this, on the single transistor stuff, what I was getting out of it was, out of the 2 transistor deal was basically square waves. So, but, you know, it could lock onto those. The PLL could lock onto those. This works. Yeah, this works. It's just, it took me longer than it should to figure it out. Nah, well, yeah. I don't know about that. I was probably getting like 5 out of this, you know, which was good enough. I was getting a 1 volt peak-to-peak signal up to about 3.5 here. So, you know, and that's on a 2N quad 2. A 3904, I had issues with problems with it chopping a lot, you know. So, LT Spice is a great tool, though. Love LT Spice. Lots of fun to have in LT Spice. So, anyways, yeah, if you do that kind of stuff about RF, I'll be golden, because I'm not an expert. I know enough to be dangerous. I'd love to know a little bit more, but I'm not going to go back to university for that. I'm too old for that. How would you like to see me in university again? Not a 20-something or a teenager and a young 20-something, but a 40-something. That would be bad. Yeah, that wouldn't be good. My university days are over. They are over. The problem with breadboards, which is why I do it in LT Spice, the problem with doing it on a breadboard is this is just capacitive and inductive hell, you know, on a breadboard. And, well, if AB5NI there will take a look at my amp and tell me what I can do to improve upon that, you know, that would be fantastic. But I know that's close. I know that's close. It's simulated well. So, you know, Just because, and that's another thing, just because it simulates. I go put it in a radio, and yeah, forget it. It's just, it doesn't work. I've had that happen to me many times. I go get it, whack it into LT Spice. Oh, it works great. And then put it together. Oh, it doesn't work. Ian, electronics tutorials. Improved AM detector is a super diode, which is an op amp. I've already done that. I wasn't very thrilled with it. I didn't do a video on it or anything like that, because I did that. If you're talking about like a super diode, or zero loss diode, which is basically op amp kind of stuff, I did it. It wasn't that spectacular. Not an SCB. I think so. I had already done something. Yeah, I had already done something very similar, and I wasn't really very. It worked, but really wasn't that spectacular. It didn't really give us. It really didn't help that much. What was I looking at yesterday? Damn iron has cooled off. I don't know how much tweaking can be done. You see, the thing about those detectors is we're not an RF at that point. We're kind of in the audio thing, to polymer and plastics. Yeah, I know. And you went to university for that. The A&L was probably not going to work with that thing in place. The super diode concept. I think I LT spiced it, and I didn't like it. I might have bookmarked it, or I might not have. Let me look if I did. I probably didn't. I don't see it. Yeah, I don't think so. No, I didn't bookmark it. It just didn't. It wasn't that great. Like, the frequency response was shite, as I recall. Yeah, I just didn't. The whole op amp, it worked, but it was not that great. It didn't really get me anything else, for lack of a better explanation. It just didn't really work. It didn't. It worked. It worked. It just didn't work as advertised. Most people think you take this op amp and some diodes and and the feedback and all that kind of stuff, and you put it in the detector. It worked as a detector. It just, you didn't get any additional gain on the receiver versus the existing 1N60s. Yes, it just didn't. You can use an op amp for the input for the PLL. It's probably going to have to be like some kind of high slew op amp or something like that. But what am I getting? An email from AliExpress. Anyway, I'll look at it later. You need a W2AW. Yeah, I know him. I think I've seen some stuff he does. If I remember correctly, he's I think he worked for, yes. The 2N222 is, just, yeah. It's the wrong transistor for the job. I was using the 2N222. He's a, yes, he works. That's right. He worked for Textronics. He worked for a test equipment manufacturer. and he good guy. I don't know him, but well, wait a minute. I think I may have met that guy. I used to go to trade shows a lot. I thought I had. Yeah, I think I met that guy years ago. You know, years ago. Mr. Carlson's lab, he covers a lot of old stuff, and that's not my bag. So I tend to look at some of his stuff, and okay, he's covering some old legacy thing. You know, since I don't play around with legacy equipment, you know, I tend to not, you know, look at what he does just because it's not, you know, not in my cup of tea. It's not in my realm. You guys have to keep in mind, I'm digital, you know, so those guys who do analog, you know, they're you know, analog to me is you know, you know, I'm not too good with the analog world, so the 1674. There's no I don't have a LT Spice model for it, so yeah, his method is the same as mine. Grab it with a pair of needle nose and twist it. That used to be the recommended, a huge joke. That is, or at least was, I don't know if it still is, the surface mount caps. Okay, this has through hole in it. Okay, surface mount caps. That was the recommended way to remove a surface mount capacitor from Matsushita. That was what we told our techs to do, was to remove them that way. That was the recommended by the manufacturer way of doing it, and that was over a decade ago or more at this point. So that's, to me, that's actually old news because, well, I was doing that 15 years ago. You know, so that one's old news. Let me see if I got something with surface mount caps, because I want to send some shivers down some people's spines. Let me see what I got. Do I have anything with fish caps? I used to call those damn things fish caps, because when they went bad, they smelled like fish. Here we go. Yeah, the equipment used to smell like fish when they would go bad. Here we go. You grab it like this, and you squeeze it, and you give it a twist, and it comes right off. See? No damage. It works perfect. You know? You'd like to see that again? Woo! Give it a squeeze, and a twist, and it goes pop, pop, and off it comes. This is old. This is something that I had from years ago. This is here we got an Altera Flex FPGA. Yeah, we've got a Hitachi, which is put Renesas now microcontroller here, and other goodies that are on this board. There's a Toshiba board. What do we got here? This is an LCD. Was an LCD, 3 LCD projector. Now that I think about it, because here's your ribbons for your LCD. Your 3 panels were in here with your prism. They were in the light engine. This one sat on top of the light engine. Yes, I used to work on this equipment, so this is why I have some of the boards still. I used to work on this stuff, including with all the bodges. This was bodge heaven. You see all the tape and all the bodge wires. Yeah, I mean, this was fun days, man. This would have been the power supply connector right here. Power supply would have come in. Power supply data for the ballast would have come in here. Control lines. The dust, It's in my parts bin down below. Doesn't really get dusty in here very much. But this is definitely a, when was this? See if we can find some date codes and some chips. It's definitely about 15 years ago, because I haven't worked on Toshiba kit since then. First month 2003, so yeah, 2003. Yeah, first month 2003 on that Altera EEPROM for the FPGA. Yeah. Yep. First month 13. Yeah, this was or 2003. I'm sorry, not 13. 2003. So, yeah. I keep it for bits and bobs. Well, it's just optical isolation, or these are inductors that are on here. That's from what we had on those tracks are all match length tracks. So yeah. So replacing caps. Yeah. Replacing fish caps. Kink, kink. I know how much you guys like that. Ooh, that one was leaking. You can see the spooge come out of it. Yeah. This is my preferred way of replacing these. Kink, kink. Oh my. You guys are... You could see the spooge under them. They were leaking. So, oh man, you should have called me. It depends on the manufacturer of rear projection sets, but you do realize I used to be field engineer for several of those companies. I may even have the manuals still for some of those sets, if it was an older set. I could have probably told you exactly what to look for. Those were my things. JVC? No, I didn't do. It's funny. I didn't do JVC. Yeah. Oh, wait. Okay. What are we waiting for? But yeah, interlock on a switch for the bulb housing. There's usually an error code. So the power LED probably flashed a pattern to you to tell you that the lamp door was open. On and off. Clicking on and off over and over. Like the lamp. If the lamp is striking, yeah, if the lamp is striking, like the lamp is going on and then going off and then coming on and going off, you got a bad lamp or you got a bad ballast. It's actually easy. That's if that's what it is. What's up, Puss Puss? Go ahead. Go ahead, Puss Puss. He's probably going to want more in a minute, but yeah, yes, the pussy wanted to go out. Lamps on rear projection, if they are if they use a what are those damn bulbs? Forget what the composition of gas that's in them. But if they're a lamp driven set, the ballast, what voltage, they run at a low voltage. They strike an arc. I don't think it's argon, it's something else. They strike an arc, and then they it's like 800 volt pulse to just strike an arc across the electrodes, and then they it takes it from there. And then the ballast just puts out a high current DC voltage that keeps the arc going. But it's actually low voltage DC. So you get a strike, it strikes it, and then it's a lower voltage DC high current that keeps it going. Yeah, usually it's good. In the case of a flashing screen, like the TV will come up, you look in the lamp, you look somewhere where you can see the exhaust for the light engine, and you're looking for whether or not you can see the lamp illuminating. If the lamp is going on, going off, going on, going off, no, I'm talking. Is this a plasma set, or is this a? You said it was a projection set, so I'm assuming it's a more modern projection set, not a 3CRT projection set, or that's, it's got a light engine. I have light engines around here because I used to work on this stuff, and I was cleaning earlier, and I found some light engines. So I'll show you a light engine. Here, let me get this stuff out of the way. Remember, I used to work on the consumer electronics, field engineer for several companies. I was the one who was in charge of the techs, so I know that's actually my game. This was out of a projector. Okay, so here's a light engine. Okay, I don't know what projector this is out of. It might have been out of that one that I've got the board. If it's a backlit LCD, those have inverters. Oh, I threw my leads in the wrong box. All right, so we got a light engine here. These are LCDs, okay? Probably very low resolution LCDs because, well, they're old. That board might have been what went to this. Anyway, so you see we got the lens, and we've got in here is a prism, and this is the optical bits of it. In here is a lamp. Actually, there is still a lamp in there. This is obviously a fan. Let's get this lamp out. I get the lamp out and the rest of it comes apart. Alright, so there's the lamp. Okay? And these suckers get hot. Boy, oh boy, do they get hot. And they're under pressure. There's the little bulb is down in there. And this chamber is to protect you from the exploding bulb, because these things explode. When they go, they go. You know about it. They do have a finite life. This is to focus and diffuse the light a little bit, and try to take some of the UV edge off, because there's a lot of UV, the white powder. This bulb hasn't exploded. They do have mercury in them. Anyway, these are like, I can never pronounce the word, but it's like a dichroic filter that are down in here. Basically, if I shine a light in here, you can see the different colors. You probably can't see the blue, but you can actually see the light coming out of the engine. That's the green component of it. And that would go through the LCD panels and obviously and so on and so forth. So that's the red component. That would be the blue. You can barely see the blue component coming through there of the light. So, see ya. Probably see it better against white paper. The blue component of the light. Yeah, you can actually see the other colors behind it. But yeah, that's the light being split into three colors through these filters. And there's some prisms and all kinds of other stuff inside of here. If you take this apart, you're going to have filters and prisms and stuff in this thing. Um, I should probably keep this just for fun. But yeah, you could see the green. You can't see the blue though. Actually, it's quite bright. Quite bright. Like it's reflecting onto the ceiling and everything. It's quite bright. Now you see the green. But anyways, these probably were together. Yes, see? And that's how that arrangement would have gone. So you would have your blue, or your blue, your green, and your red image here into a prism to be recombined in and out the lens. So if I shine a light in here, nothing's really going to come through it because you can't see anything coming through it because the LCD panels are not on, but there you can see it. Anyway, so yeah, I might keep this light engine. I know I threw out a few other ones, but maybe I'll keep this one. This one just didn't make it into the rubbish yet. This would have been to a standalone projector. These projectors probably didn't have anything more. They were probably VGA, maybe SVGA at the most projectors. So anyway, I don't know what the resolution of these panels is. I could probably find out. Let's see. Do we have any numbers on these? I don't know. They're dirty, I can tell you that. Don't know what color's what. I think they're all the same, actually. No, they would be all the same because they wouldn't need any different to be different color. It wouldn't be a need for them to have different colors. This would obviously be in red. It's got a red dot. This one probably is missing its green dot. And that says blue dot. So maybe they are different. 09 XG260, 09, yeah. 09 XG250, 09 X0260. So yeah, they're different LCDs. But yeah, and this cooling system here would be to cool the LCD panels. And they weren't cooling the LCD panels. These little air ducts under here were blowing onto the filters to keep the filters cool, because they were absorbing light energy of other wavelengths, and they as a result get hot. So anyway, that's light engines. Kind of cool stuff. Maybe I'll keep them, maybe I won't. They were next to the door to go to the rubbish. So anyway, guys, it's late. I probably need to look at my thing for the last time to see if it's going to show up. And if it's going to show up, I'll tell you guys to come to check in tomorrow, and we'll see. Let me check this again. Amazon says arriving tomorrow by 8 p.m. Yeah, I'm just not a believer that it's going to show up tomorrow, but you know what? It could. And if it shows up, that'll be great. I think you guys will like what I have in store. I think it'll be a lot of fun. And yeah, I'm just not a believer that's going to show up tomorrow. If it does, great. I think Monday is probably what's going to happen. I just don't want people to set their clock and say, okay, come by, see what's going on, and yeah, no problem. But I still want to see you do some RF stuff on your channel. You're going to do it, right? Tell everybody you're going to do it. Go ahead and tell everybody you're going to do it. You will do it good. Hey, the LT Spice that I held up that you took a grab, that you took that grab of. I would be curious that you, if you're an RF guru, that you take a look at that. That we need that to operate round up like up to 3 megahertz, which I believe it will do. We need to take something that anywhere from like half a volt to half a volt peak to peak signal and bump it up to like, a few volts at least. That shouldn't be too hard, but that should work. And I think that worked fine in LT Spice, but I have not actually assembled the circuit. There you go. That would be perfect. That would be perfect. That would be perfect. Alrighty. I look forward to it. I really do. Guys, it's been a pleasure. As always, tomorrow I hope to have something really cool. If I don't, I will be upset. But I will get over it. I think you'll like it. But I want to make sure it comes before I say, yeah, show up. So, if I get something during the day, I'll put some video up, some little short blurb, hey, tune in tonight. If you see it, good. If you don't, I didn't get it. And maybe Monday. Good night, guys. You guys have a good day, good night, whatever it may be, wherever you are. Cheers for now. Thanks for watching. Catch you next time.